Tata Steel Operations. And Dr. Mishra is the head of operations of steelmaking at Tata Steel BSL. And I think Mr. Aditya Soni has also joined. Dr. Mishra, good afternoon.
Good afternoon, Devaji. Thank you. Thank you.
Yeah. Good afternoon, Mr. Soni.
Hello. Good afternoon.
And a
Good
warm
afternoon.
welcome to,
Good afternoon to all.
yeah. Mr. Aditya Soni is the head of sales and marketing, Central and South Asia for Calderys India Refractory Limited. Am I right?
Yeah. Central South India.
Okay. Central and South India of Calderys India Refractory Limited. Thank you, Mr. Soni. I think who else? Oh, no one else has joined so far. So let's wait for another 13 minutes. It's 3:17 by my watch, so another 13 minutes. Okay. So Ankit, in the meantime, just check because I can see 55 in the participants list.
Yeah.
So if there is any panelist who is there in the audience, can you upgrade them to panel status?
Yep.
Just have a look.
I don't see at the moment, but I guess we still have 12 minutes to go, so people will be joining in the meantime.
Yeah. So Dr. Janash is from Smart Steel Technologies. And Ankit, I think in our last webinar, we had a speaker from Smart Steel Technologies. Do you remember?
Yes, of course.
So this is the second. I think last time it was your CEO, Dr. Otmar, who was there.
Right. Last time it was Dr. Falk Henrich, who is our CEO.
Yeah.
And I'm the vice president and metallurgist in the team.
You're the vice president for the metallurgy team, right? So I think Mr. Santosh Mundhada is also joining. Santosh ji, namaskar and a warm welcome to you. Okay, Mr. Mundhada is yet to join, so he's joining very soon. I can see Mr. Mundhada trying to join in. Mr. Mundhada is the executive director, and he is the head of the ArcelorMittal Nippon Steel plant of Hazira. This was earlier SR Steel, which was acquired by ArcelorMittal Nippon Steel at the end of 2019. And now, this is a plant which is I would say one of the largest plants of ArcelorMittal that they have in their fold right now. It's a 10 million ton plant. So ArcelorMittal Nippon Steel will be represented by Mr. Santosh Mundhada, the Executive Director, Hazira Operations. And Ankit, just keep a watch. If anyone is there, please update them. Mr. Mundhada, namaskar.
Namaskar. How are you, sir?
I am all.
Nice to see you.
Yeah, great to see you also again. And it's always a pleasure to have you on board with us. And I was just explaining the significance of Hazira operations in the ArcelorMittal Nippon Steel fold. It's I was mentioning, it's a 10 million ton plant, and the operations are doing fantastic. The company has been performing very well. The Hazira operations have been doing very well, and congratulations to you, Mr. Mundhada. Under your leadership, the plant is doing wonders, and I'm sure in the days to come, it will be a flagship plant in the AMNS fold.
Thank you very much for your kind words and your best wishes. And people like you keep on always encouraging us to perform better,
Yeah. Thank you, Santosh ji. So, Ms. Saxena Saab, namaskar and a warm welcome to you.
Namaste, sir. I am Dr. Bhaskar. Sir will be joining in a while. Just within 1 minute, he will be joining.
Perfect, perfect, no problem. So Mr. Saxena is the Director Operations of Vizag Steel Plant, which is Rashtriya Ispat Nigam Limited. And our guest of honor is joining right away. I can see him. A warm welcome to Dr. Saraswat, Dr. V.K. Saraswat, our guest of honor today. Sir, a warm welcome to you. Dr. V.K. Saraswat is the member of Niti Aayog, and he is better known as the Missile Man of India. And a man with immense and vast knowledge, a technocrat through and through. So a warm welcome to our Mr. Kasaknola, good afternoon and a warm welcome to you.
Welcome.
Yeah,
hello. Can you hear me?
Hello. Yes, Cristiano, we can hear you loud and clear. So you are joining us today from Italy.
Yes.
And we have Mr. Prabhat Ghorui. Prabhat, namaskar.
Namaskar. Good afternoon, everyone.
Yeah. And a warm welcome to you. Mr. Prabhat Ghorui is Senior Vice President of JSW, based out of Hazira, and he is responsible for TQM, Total Quality Management, and Excellence. JSW Vijayanagar. And he is responsible for the entire TQM steelmaking and technology part. So, so to say, he is I would say, a thorough technical expert through and through. So warm welcome to you. And Dr. Saraswat, our guest of honor, has already joined us. Mr. Aditya Soni has also joined us. Mr. A.K. Saxena, Director Operations, Vizag Steel Plant, has also joined. Dr. Otmar Janash, Executive Vice President of Smart Steel Technologies, has joined us from Germany. Which part of Germany are you from, Dr. Janash?
Our company is in Berlin.
In Berlin, okay. Very close to where my son is. My son lives in Magdeburg, which is around about 1 hour from your city.
It's an hour by car.
Yeah, that's right.
And an hour and a half by train, yeah.
Okay. So I think we are about time. 6 minutes to go. Ankit, in the meantime, you can get ready so we don't waste any time in starting. Dr. Saraswat, of course, needs no introduction. Dr. Saraswat has been with us. This is a third webinar he is joining us. And we've specifically wanted Dr. Saraswat because he is a policymaker and a decision maker when it comes to choosing our right steelmaking route in the days to come. When you're talking about 300 million tons as national steel policy requires us to do. So to meet the challenges of the national steel policy, we need to choose the right steelmaking route, which will give us the opportunity of energy savings, which will give us an opportunity to find out where we can reduce your carbon footprint, where we would be able to optimize our natural resources and use it effectively. So we have Dr. Matke, Dr. Andreas Matke also joining us, and the Managing Director of Polworth India, Mr. Anil Anand, has also joined. Anilji, namaskar and a warm welcome.
Namaste, namaste. How are you?
I'm fine, sir. All well. So
you are doing I have to say this. You are doing a wonderful job during this pandemic time, and you have really kept the steel fraternity live with your various webinars, your talks, your continuous messages. So hats off to you.
Thank you, Anilji. That is my job. My job is to bring this industry together. And I always keep saying the future of steel lies in India. So having said that, let me also state that I want to make sure that we don't take wrong decisions while on our growth path. We take the right decisions at the right time to optimize all our resources and be the #1 lowest cost steel producer in the world. So with that, Ankit, I think...
Ankit, sorry, I have a question.
Yes, please, Cristiano, go ahead.
No, I have sent via email my presentation because I have
some troubles to share with Zoom. Would it be possible that somebody from your end shares during my speech?
Yes, Ankit will do it. My son will do it. Ankit, can you just share your email ID with Cristiano so that he can send you the presentation? Ankit, can you hear me?
Yeah, sorry, I just got a call. Yeah, I will send the email ID.
Yeah, you send your email ID to Cristiano, and Cristiano will send his presentation to you, so that you can share the presentation when.
Thank you.
Cristiano. It's done, Cristiano. No problem. So with that, do we have all the panelists together? Can we get Mr. Prabhat Ghodui? Dr. Matke, can you hear us? Dr. Andreas Matke? Dr. Matke, can you hear us? Dr. Andreas Matke is.
Can you hear me?
Yes, yes, Dr.
Okay.
Matke, we can hear you.
I have sometimes some trouble with my microphone, but I will handle, I think. No problem.
We can hear you clearly, no problem.
Okay.
So Dr. Andreas Matke is the Vice President, Global Technical Services at Dalmia OCL, Germany.
Yes.
So with that, I think we are about time. We are only waiting for Mr. V.R. Sharma to join. So Pradipta, if you could just follow up with Mr. V.R. Sharma's office, then we have another 2 minutes to go. It's 3:28 by my watch. So another 2 minutes to go. So maybe Pradipta can follow up with Mr. V.R. Sharma's office to see if he is joining. Okay, so Pradipta, if you could just follow up with Arunesh to check if Mr. V.R. Sharma is joining. I'll send a WhatsApp message to Mr. Sharma.
Mr. V.R. Sharma will be joining by around 4 o'clock. So I think we can
start. Then
yeah.
We can start. Yeah. We can start. Ankit, if you're ready, please go ahead.
Yeah.
And Dr. Saraswat, sir, आपका permission से, if you give us permission, we'll get started.
Yeah, please go ahead. Namaskar. Please go ahead.
Namaskar, Dr. Saraswat.
Yeah. Okay. Yeah. So good afternoon and a warm welcome to all the panelists and the attendees who have joined us today, and to everyone watching on our live stream on YouTube. We welcome you all to our 29th webinar. I think we are having some feedback on the microphones, or?
Yeah, you can mute everyone except Dr. Saraswat.
Yeah. Okay. So yeah, we welcome you all to our 29th webinar titled BOF versus DRI Scrap-EAF Steelmaking Routes, organized by Steel and Metallurgy. A warm welcome to our silver sponsors, Jindal Steel and Power, ArcelorMittal Nippon Steel, Prime Metals Technologies, our steel sponsors, Polworth, SMS Group, Danieli, Calderis, Maxis Motion, and our refractory partner, RHI Magnesita. I would also like to welcome the chairman of our organizing committee, Mr. Subhrata Mitra, who is the ex-joint managing director of Eben Dastur & Co. At the moment, he's tied up in another meeting and will probably be addressing us later today. I would now like to introduce our panelists for today. So first we have our guest of honor, Dr. V.K. Saraswat, Honorable Member of Niti Aayog, Government of India. Our keynote speaker for today, Mr. V.R. Sharma, MD and CEO, Jindal Steel and Power Limited. Mr. A.K. Saxena, Director Operations, RINL, Vizag Steel Plant. Mr. Ravi Singh, CEO, Sulp Steel, Bahrain. Dr. Siddharth Mishra, Head of Operations, Steelmaking, Tata Steel, BSL. Mr. Santosh Mundhada, Executive Director, ArcelorMittal Nippon Steel, India. Mr. A.K. Bhatta, ED Projects, Bhilai Steel Plant, SAIL. Mr. Prabhat Kumar Ghodui, Senior Vice President, Technology and Excellence, JSW Steel Limited. Mr. Shibu K. John, Vice President, Strategy and Business Development for the upstream business of Prime Metals Technologies. Mr. Anil Anand, COO, Region India and Asia Pacific, Managing Director, Polworth India Limited. Mr. Cristiano Castagnola, Senior Vice President, Iron Making Polworth. Mr. Deepak Bhatnagar, Secretary General, Pellet Manufacturers Association of India. Mr. Enrico Plazogna, Executive Vice President, Sales, Danelli Automation, SPA, Italy. Mr. Alessandro Martinez, Vice President, Danelli Centro Metallics. Dr. Narendra Kumar Mishra, R&D Head, India, West Asia and Africa, RHI Magnesita India Limited. Mr. Aditya Soni, Head, Sales and Marketing, Central and South Calderis India Refractories Limited. Dr. Andreas Mertke, Vice President, Global Technical Services, Dalmia OCL, Germany. Mr. Sanjeev Manocha, Global Steel Industry Manager, Carmiusi. Dr. Otman Yanash, Vice President, Metallurgy, Smart Steel Technologies. So these are our panelists for today. Before we proceed, I would like to share a few short guidelines for smooth platform management during today's proceedings. So for all the numerous attendees who have joined us today on Zoom to listen to our discussion, we have a Q&A section, which can be accessed by all the panelists as well as the attendees. So I would request everyone to post your questions and queries in the Q&A section or alternatively in the chat, and it will be visible to all the panelists who can choose to either answer it live or directly in the chat. I would request all panelists to keep their microphones muted when the other panelists are speaking to avoid any kind of noise feedback. Last but not the least, since we have a lot of panelists today, I would request everyone to adhere to the time limit as given in the program to avoid any unnecessary delays. Our session moderator for today's discussion will be my father, Mr. Nirmalya Mukherjee, Editor, Steel and Metallurgy. On behalf of Steel and Metallurgy and our sponsors, I would like to welcome you all to this webinar. So we start off with some videos from our silver sponsors, but before that, I would request you all to please rise for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Yeah, so we have a few short interesting videos from our sponsors, and I will now play them for you, starting with ArcelorMittal Nippon Steel, followed by JSPL and Prime Metals Technologies.
The second wave of COVID-19 hit India very hard, and its ferocity caught the government, the medical fraternity, and the people by surprise.
Severe second wave of COVID-19 is threatening to overwhelm the country's health systems.
The rate of increase in the new cases is significantly higher in the second wave of COVID.
Many parts of the country are reporting hospitals being overwhelmed, oxygen shortages.
Combating the second wave required all hands on the deck, all resources to be pooled to provide support and pull the country out of the crisis. And in this hour of need, ArcelorMittal Nippon Steel India came forward to stand in solidarity with the people and the government, not just in lip service, but in on-ground action. Most critical of supplies needed was oxygen, of which there was acute shortage across the country. To this end, our facility in Hazira, Gujarat spearheaded our efforts by supplying over 200 metric tons of liquid oxygen every day to medical units in need, which was soon stretched to 250 metric tons per day. From the onset of the second wave in April till date, the amount of liquid medical oxygen supplied by us is equivalent to oxygen requirement of nearly 9,20,000 patient days. Increasing caseload was leading to scarcity of hospital beds. We stepped up and set up a 250-bed hospital near the Hazira plant in just 72 hours.
मेरे को याद है कि प्राइम मिनिस्टर ने मोदी जी ने मीटिंग की थी और उसमें कुछ इंडस्ट्रियलिस्ट को बोला कि आप क्या कर सकते हैं, ऑक्सीजन की शॉर्टेज है, आज कमी है, और हमने तुरंत अपनी टीम को इस काम के लिए लगाया। ये एक नई आइडिया आई कि एक हॉस्पिटल फैक्ट्री के बगल में ही बना दिया जाए।
3 दिन में 250 बेड वाली हॉस्पिटल आप लोगों ने जो व्यवस्था बनाई है कि आने वाले दिन में 1000 बेड वहां ही आपकी इंडस्ट्रीज में ही इतनी बड़ी हॉस्पिटल विथ फुल सपोर्ट।
The hospital is equipped with gaseous oxygen, has WHO certified doctors and nurses to offer the best care to the patients, and can be scaled up to 1,000 beds.
3 weeks back, Surat faced one of its worst oxygen crisis. Every 3 hours, we would be at a situation where we would face the dilemma where the next oxygen cylinder after 1 hour is going to come from. And that is when, luckily for us, AMN has stepped in to provide us with the necessary oxygen. And here, the biggest advantage is that there is no short supply of oxygen. So that has proved a real boon.
I got all the best facilities over here. There was no problem for my recovery, and I have recovered very well, and I will be discharged today.
Our efforts were not restricted to just one location. The oxygen was transported across states in cryogenic containers. Over 7,000 oxygen cylinders were imported. Life-saving drugs, PPE kits, sanitizers, masks were also distributed in various states to smaller hospitals and also the frontline workers. The situation is still grim, we know, but we have all joined hands to fight it together, and we shall overcome.
We at ArcelorMittal Nippon Steel are determined to stand shoulder to shoulder with the government of India and its people, and we will leave no stone unturned in overcoming this particular crisis.
Thank you, Ankit. Before you play the next video, I must compliment the Indian steel industry for what it has done over the years. I mean, during this period of crisis, every steel maker of this country, be it Vizag Steel Plant, be it JSPL, JSW, ArcelorMittal Nippon Steel, SAIL, every steel maker of this country came together because of having a big advantage of having access to industrial oxygen with 99.9% purity. We were able to deliver well on time to this nation. So salute to the steel industry of India, which has done so much during this period of crisis. So Ankit, let's go on to the next presentation.
So our next video is by JSPL.
Thank you, Ankit. And once again, JSPL needs a special applause because of the performance they have done in this first quarter of this year. The results of first quarter, April to June, are just out. And they have improved their profitability tenfold, 10 times. And they have reduced their debt burden to 15,000 crore. And by the end of this year, JSPL's debt burden will come below 10,000 crore. So a great achievement indeed during such difficult times, excellent performance. So congrats to JSPL Collective. The managing director of JSPL will be joining us very soon. But Ankit, you could play the Primetals presentation before we go on to our keynote, our guest of honor for today, none other than Dr. Saraswat. So before that, just the last video.
Yeah.
Before
So the
Dr.
last
Saraswat.
video for today we have from Primetals Technologies. I will be sharing that now.
It takes a sense of adventure to conquer true innovation, to find a path that no one else has walked before. We explore new possibilities. In the face of obstacles, we turn challenges into opportunities, and we will persevere until we've reached our destination. The steel plant of tomorrow. This is a plant that is fully automated. It benefits from cutting-edge digital technologies and brings transparency to the entire production process. It uses synergies between the most advanced solutions in steel production. The result is unparalleled efficiency and end products of the highest quality. This plant of the future illustrates our determination to push the limits in the world of metals. Together with our customers in the metals industry, we are on a journey of discovery. Together, we explore what's next. We are pioneers at heart. Primetals Technologies.
Yeah.
Thank you.
Thank
you, Ankit.
I would now request our session moderator to take the session forward. Over to you.
Thank you, Ankit. With this, let me also mention that Primetals is, earlier it was known as Siemens VAI. Before that, it was VAI. So Siemens took over this company, and later this company was, majority stake was acquired by the Japanese Mitsubishi Hitachi together to become Primetals, which is headquartered in London. And their center of excellence lies in the city of Linz in Austria. So again, Primetals is a part of the big three darlings, as we call them. The three darlings are Primetals, SMS, and Danieli. So these three players together constitute the majority of steel plants built all over the world. So with that, we come to the beginning of the session. And today we have none other than Dr. Saraswat, who needs no introduction whatsoever, not just a member of Niti Aayog or a policymaker of the government, but a person who's a thorough technocrat. And as I mentioned right at the beginning, he was better known as the missile man of India, who headed the DRDO. And he is a person with immense knowledge. And those of you know from the earlier two webinars where he had addressed us, one was on hydrogen, the other was on refractory industry. And he goes into the depth of the subject. And today, when we had to choose the right steelmaking route, we could think of no other than Dr. Saraswat to lead us, to guide us where this industry should be going in order to reach those 300 million tons. What is the way forward? Should we choose only the blast furnace BOF route, or should we have a combination of BOF as well as the DRI module, India in any case, it's the largest DRI producer in the world. But the challenge is, I think Mr. V.R. Sharma will also explain, if we could use whole gasification as the way forward, because we do not have enough gas to have gas-based DRI modules as of now. I think Ravi is here. Ravi heads a steel plant in Middle East, where gas is adequately available, where we could have enough of the gas-based modules. But in India, we need a mix and match of all these technologies together. So without wasting much time, I would like to leave the floor to our guest of honor and the person with immense knowledge, Dr. Saraswat. Dr. Saraswat, namaskar, and the floor is yours, sir.
Namaskar, and very good afternoon to all the luminaries of the steel world. I have some of the very prominent personalities from Indian steel making and also from the globe. So my greetings to all of you on the early days of India's 75th Independence Day celebration, which is slated on 2 days from now. It's one of the major years for us, and as all of you know, steel has really made a great impact on the journey of India towards a developed economy. I have a small presentation, if you gentlemen will allow me, so that I can share my screen with you, and then we can discuss the subject of blast furnace, waste system, and things like that. So,
sir, please, you can use the share screen option, sir.
it's open now, but it is still in some funny mode. Have you done it in PDF? Next slide. Okay. So I would like to start. Are you seeing my screen? Can you see that?
Yes, yes, we can see.
So the topic today is the blast furnace, BOF versus DRI scrap and EF steel making roads. And as the moderator has said, I think we have to make the choices. But the biggest focus today, all of us know that steel is one of the most trusted material, and it is one of the most oldest metals used by men, and remains to this day the most trusted and versatile material in manufacturing. It is the only reliable but the preferred material in a wide range of industries. The steel industry has been reducing the need for raw materials and encouraging reuse of existing products. Steel is the world's most recycled material. So steel has four major elements: the durability and the quality, the recyclability, the design flexibility, and the cost efficiency, as we call it. Looking at the global status of steel and where does India stand with respect to, and what is the kind of share of various processes which are being followed today for manufacturing steel is given here. You can see in the status, China, of course, in the crude steel, the highest 996 million tons, and India is about 111 million tons sitting there. We make about 6% of the global share, but the line number, the vertical line number 3 and 4 are very important, which indicates what is the share of blast furnace oblique BOF share vis-a-vis EF share. You can see that in China it is 90 and 10. In India it is 44 and 56. And there are countries like Korea where it is again 68 and 38 and so on. And then there's also in the fourth column, we have given the percentage of DRI in EF. So you can see that there are various countries following different routes as far as the manufacturing of steel is concerned. But even today, predominantly, you can see that the blast furnace route is in majority of the nations except for North America and India, of course, another one where we are still blast furnace is reduced less compared to here. But otherwise, most of the places it is the blast furnace route which is predominantly used for the production of the steel. The steel production, of course, as all of you know, it has got the number of numerous process steps that can be held, laid out in various combinations like product mix, available raw materials, energy supply, and investment capital. These are some of the parameters which actually dictate. But the key characteristics of these three major steel manufacturing routes are like the blast furnace and the basic oxygen furnace route, where the big iron is produced using the primary iron ore, which is about 70 to 100%, and coke in blast furnace, and then turned into steel in a basic oxygen furnace. Due to the inclusion of the coke making and sintering operations which are involved in this route is highly energy intensive. Second one is the scrap electric arc furnace route, where primarily we use scrap for iron input and has lower energy intensity compared to the blast furnace route due to the omission of coke making and iron making process. That is the reason why it is so. Then of course the third route is the directly reduced iron and the EAF route based on iron ore and often scrap for the iron input. Energy intensity of the DRI production can be lower than the blast furnace route depending on the size and the fuel and the ore characteristics. This is a diagrammatic representation of how the three processes work together. I think most of you are from the steel industry, so I don't have to go into the details of that. But the fact remains that each one uses different kind of inputs. For example, the blast furnace route, you have got coal and coke and sinter and pellets which are coming. Whereas in the other one you have pellets, then you have if you divide that into the DRI and the EAF route, you get directly the secondary production which is directly into the EAF. So you can see from each of these, I think somebody was talking about use of coal from the natural gas. I think, like for example, in the case of direct reduction, the natural gas is predominantly used in the shaft furnaces and things like that. So in fact, we proposed that why not we go for, instead of natural gas, the gas produced from the gasification of coal. And we had discussion in the Ministry of Steel on this subject. And there were a lot of people from the steel industry who were very keen to get this done. And that could have been one of the experimental plants which could have been generated. But I think probably we lost way on that subject. But even today, it is not late if some of the plants which are presently using gas can be converted to work on coal. So coal gas to gasification process. You can see the energy intensity of each one of them is given there. How much of energy intensity? For example, the first one is 26.4 to 41.6. The second one is 19.8 to 31.2, and that is the DRI and the other route is EF route is about 28.3 and 30.9. Whereas the secondary steel production using the recycled steel EF is the least, which is 9.1 to 12.5. That is the kind of numbers we had as far as that. Why I'm talking of this? Because the present requirement is to basically how do we make the steel production more cost effective, most competitive, and make it more efficient. And most important thing is how do we reduce the impact of carbon emission of carbon dioxide in the whole process so that the environmental control can be achieved. So BF blast furnace versus DRI, if you look at it, there are two figures where we say BF must be taken in terms of cost when you do it together with the coke ovens and the sinter plants. So in the case of BF, you see raw material consumption in tons per ton of iron ore is about 3.5. Thermal energy, which is of the order of 5.4 gigacalories per ton of iron, and pollution is about 300 milligrams per normal meter cube. That is the kind of pollution we are having. In the case of coal-based system, DRI, we have raw material consumption in tons per ton of iron is about 5.08. Thermal energy is about 7.5 gigacalories per ton, and pollution norms about 100 milligrams per normal meter cube. This is the kind of comparison we have. In terms of what are the connections between the primary and the secondary steel production, you can see the broader lines and the thinner lines. For example, you can see in the EAF process where the iron ore and scrap is largely used, that's why the line is thicker, and it produces secondary steel, and primary steel output is smaller. When you take the BOF process, you have a red line which is iron ore based. Iron ore is maximum, and it produces primary steel and very small quantity of the secondary steel. That is a kind of correction. But the scrap is common in both the cases, so that makes the connection, and you get the steel pool, which is the primary and the secondary steel. The various options to reduce carbon dioxide emission in the steel making are shown in this graph. For example, you have the first one where you have on the right hand side the electric arc furnace, and in the bottom you can see the blast furnace and the basic oxygen furnace route. But the inputs are common. For example, the iron ore is going in both cases, and the power plant which is supplying power is also providing for the electric arc furnace as well as for the direct reduction plant and so on. So conventional BOF route with carbon capture and CCS is one possibility of reducing the carbon. That is, if I can integrate this with CCS. Conventional BF route with carbon capture and utilization. It is another one which we are important. Utilization means I should be able to make use of the carbon dioxide and other gases for making some very useful products like chemicals and so on. Even then, use of biomass, if you do, then again you can reduce because then the coal is reduced, and then you have the biomass emits less carbon dioxide, so you will be able to reduce the carbon dioxide. Then, as today's debate is, shift to EAF route, because we have seen the energy intensity there being lower, so you will have less of carbon dioxide there. Otherwise, you have to go for electrotwinning or hydrogen direct reduction, which are the two technologies which we'll discuss later. But basically, they are, as on today, on the cost effectiveness basis. Probably one has to weigh the pros and cons, because hydrogen, if you use for direct reduction, at the present cost of electricity, as we discussed in the last webinar, has got implications vis-a-vis the output cost of steel, because it is going to affect about 20% to 30% extra. So that is the present situation. But over time, I think that the hydrogen costs come down with the renewables coming more and more into operation. I think this becomes one of the most selected route. When you see the individual performance of how much is the CO2 emission from the steel production, you can see that the integrated steel making route, the total steel carbon dioxide production is about 1.9 tons per ton of steel. And how does the breakup take place? If you take the raw material preparation, take the coke plant, it is 0.3, pellet and sintering plant is about 0.2, line production about 0.1, blast furnace about 1.3, and BOF is about 0.1 and so on. If you take the electric arc furnace, the total carbon dioxide production is about 0.4 tons per ton of steel. And process emissions from the carbon in the steel itself and from electrodes, as well as indirect emissions from the electricity production, all have been taken into account. Of course, you have ultimately the continuous casting and the hot rolling process, in which high temperature heat emissions also take place, which is also responsible for certain amount of CO2 coming out. So this is the kind of breakup in terms of CO2. So if one has to make a choice with respect to the carbon dioxide emissions, the choice seems to be obvious. The same thing has been pictorially shown here in terms of tons of carbon dioxide produced per ton of steel. For example, BOF, it is 2.3. BOF with best available technology, as I had shown in the previous graph, is 1.9. And BOF with biofuels, if you use it, is 1.1. Directed reduced iron, it is 1.1. BOF with carbon capture and storage, if you take that process for saving the carbon dioxide, will come down to about 0.9. And electric arc furnace, as we mentioned earlier, 0.4. And EAF is zero carbon electricity. That means the grid is completely decarbonized. You are using maximum renewables in that, you will get less than 0.1. So that is a kind of a breakup. So that also helps you to make a choice vis-a-vis the CO2 emissions are concerned. The expected reduction in CO2 over a period of time, what is going to happen is given here. These on the y-axis, you have got carbon dioxide emissions per ton of steel, and you see three lines. The first line is thin line, which is you can see the carbon-based steel making is the highest emissions, which is on the leftmost corner, whereas the energy consumption is the minimum there. When we take the carbon capture and storage utilization using the renewable energy, you get less carbon dioxide emissions. Hydrogen-based steel making will be the least, and carbon capture and utilization, although the electric power consumption will be high, but the carbon dioxide emissions will be almost comparable to the hydrogen-based systems. So this is the kind of numbers you can get. So CO2 reduction is about 70% in CCS and CCU route, 85% in the hydrogen-based steel making, and 85% again in the CCU route. So there are two options for reaching zero emissions. One is hydrogen-based direct reduction of iron and electric arc furnace-based steel production. Produce iron via the direct reduction process using clean, preferably green hydrogen as reducing agent. Produce steel using electric arc furnace and source all heat and electricity inputs from the renewables. That's more important, because today, even for producing heat and electricity, our thermal power plants are coal run, and they are responsible for a significant amount of carbon dioxide emissions. Second option is capturing and storing the process and waste emissions using renewables for energy. That is another one. Apply CCUS to the existing iron and steel production and source all heat and electricity inputs from the renewables. So that is the second option. What is going to be the emerging scenario with respect to time? If I don't want to go into the details of each of these blocks, but what is shown here is each block shows you what is the steel production cost breakdown per route. This is a European figure which has been given in euros per ton. So you can see that integrated road, the blast furnace and blast oxygen furnace, is about 412 euros per ton. And the costliest is our NG, DRI, EAF, hydrogen plus CCSU, which is about 700. In between, you have got blast furnace plus hydrogen injection plus CCSU, 549. And natural gas DRI, EAF plus CCSU is about 571. And hydrogen DRI, EAF is about 659. Other blocks, of course, give you what are the electricity, what are the capex, and things like that. And it is likely to change scenario with the changing cost of the electricity and the changing cost of the carbon dioxide as it is emerging tomorrow. The integrated route will become 538, and the most costliest one, which was NG-DRI-EAF plus hydrogen, will go to 676, and so on. So there's going to be significant, not all that significant difference between 2020 and 2030. But the main thing is what each nation is going to give credit for the carbon dioxide. And the cost of carbon dioxide, if it is changing, this number is going to be significantly different. So the steel producers are evaluating decarbonization strategies. And as I mentioned to you, the blast furnace, CO2 reduction, biomass reductants, carbon capture, in the BOF, make efficiency improvements to optimize BOF operations. And this is one thing which many of us have been trying. And that's why we got two figures, 1.9 and 2.3 of the carbon dioxide emission, depending upon the kind of processes you are following in the BOF route. For example, you can optimize BOF inputs like DRI scrap ratios, increase fuel injection in blast furnace, for example, hydrogen and PCI and so on. And currently, all this technology is available. Biomass, use biomass as an alternative reductant for the fuel. And this is called Technode process. Process possible in countries like South America and Russia due to excessive availability of the biomass. Then, as I mentioned to you, the carbon capture, fossil fuels and emissions and create new products. Bioethanol can be done from production of carbon dioxide and not available as an industrial scale today. When you look at full decarbonization strategy, which is the electric arc furnace, there you should maximize secondary flows and recycling of the melting more scrap in the EAF. EAF uses to melt scrap, that is our example, and today technology is readily available. DRI plus EAF using natural gas, here increased usage of DRI in the EAF, and current DRI plus EAF plants using natural gas. Again, here is the point what we are talking of. If you can do coal and also do CCU, then you will have significant advantage. And DRI plus EAF using hydrogen, there again replace fossil fuels in DRI process with renewable energy of hydrogen. There are two major processes which are emerging, like Midrex DRI process running on hydrogen and HYL DRI process also running on hydrogen. These also technologies available. The steel industry today is zero emissions and flexibility with the hydrogen reduction. The steel industry faces a big challenge of reducing its CO2 emissions to zero, and breakthrough technologies are needed alongside efficiency and demand reduction measures in order to meet decarbonization goals. Several European R&D projects are now looking into possibility of using hydrogen for steel production. In Sweden, what we call it a hybrid initiative aims at developing an entire fossil-free value chain for steel on the basis of hydrogen direct reduction and electrolysis. Hydrogen direct reduction is a relatively unexplored process. The principle behind HDR is to operate a natural gas-based reduction with hydrogen from electrolysis instead, a changeover which has not been demonstrated industrially up to now. And this is how the hydrogen HDR system is there. I won't go into details, but I think you know that we can do hydrogen directly into the shaft furnace, and then that can come into the electric arc furnace, or you use water electrolysis and produce hydrogen and provide for the reduction process. The most important thing is hydro more works. This is one thing which is people are recommending today. Lignite and iron ore are combined with dried using cold dry process to form composite pellets, and composite pellets are continuously fed to furnace, and the gasification of the volatile matter in the lignite produces hydrocarbon gas such as methane, and catalytic thermo decomposition of the hydrocarbon gas produces hydrogen, and then this hydrogen reduces the iron oxide to the iron, producing water and water gas. Reactions within the retort result in the chemical looping of hydrogen, amplifying reduction reaction. Much of the carbon is deposited in solid form, reducing carbon dioxide emissions. This is the advantage of this particular process. So, hydromore process use lignite as a reductant and heat source, dominated by hydrogen reduction, and most of the carbon from lignite is deposited in solid form. It employs a vertical furnace that works with natural chemistry of brown coal to produce hydrogen in situ, and hydromore plant incorporating coal dry as its front-end raw material preparation stage is up to 40% less capital intensive than an equivalent capacity blast furnace or coal-based DRI plant. Relatively low operation temperatures, smaller equipment sizes, reduce material capital cost, land area of the plant. Very low water consumption compared to the DRI technologies. The other methods which have become popular are the direct reduction in an interim step towards zero emission steelmaking. The two processes are Midrex and the Energeron. Midrex can be configured to use coal, natural gas, or hydrogen. The pitch by Midrex is for end users to establish a facility using natural gas, then move to 100% hydrogen when it becomes available at affordable prices. Energeron is designed to take natural gas and crack it via a nickel catalyst to produce hydrogen and carbon monoxide, which is used to reduce the carbon. And you can see the cost intensity in these bar graphs. You can see blast furnace, you can see Midrex, and then you see Energeron, and you see hydromore. The minimum is, of course, you can see hydromore and EUR. So you have to make a choice in the future what you would like to make based upon this. Hydromore is again given in the table also. The blast furnace, BOF, DRI, EAF, and hydrogen EAF. You can see that CapEx, OpEx, sales, ROI, in all cases, the base case, of course, is the DRI EAF. Even the return on investment under the 130%. whereas return on investment in the coal dry hydro EAF plus power generation is 250%. So that is, and capex and all that are significantly lower. So this gives you hydro is cheaper than both the blast furnace and the DRI kiln route. So this gives you an answer where should be our future, where is our future line. So what is the road ahead? Whatever will be the path towards decarbonization and thus sustainability of the steel production globally, it has to follow technologies and solutions that need three requisites: affordability, scalability, and circular economy. The share of the scrap-based EAF should increase as this process maximizes secondary flows and recycling by melting more scrap in EAF. EAF producers are more environmentally friendly and flexible to the ups and downs of the demand. Research efforts should focus on how to identify additional applications for residual streams like slag, dust, sludge. I remember having attended a major webinar on how to, monetize the slag and other things. From EAF, in order to lower the impacts of unintended consequences by new legislation or by more stringent controls in full respect of the environmental safety and human health. The ferrous scrap accounts nearly about 60% of the cost of EAF steel making process. However, there is still a huge room for improving the operations within the steel making scrapyard facilities. The predicted growth of the steel production by EAF technology, energy sources such as electricity will become more and more strategic. Thus, research efforts towards energy efficiency and optimized use of electricity are of primary importance. Energy losses through the heat dispersion are still a relevant part of the inefficiency of the EAF. About 25% of the total energy in the EAF process are due to the sensible heat and chemical energy losses via the EAF of gas. Technologies to recover these energy losses via heat exchangers for steam generation to be used directly in the steel plant for district heating or for electricity production should be optimized. It's not. Are you able to hear me?
Yes, we can hear you, but the slide is.
The slide is not changing. I think
Yes.
something went wrong with the slide. Yeah. In the case of green hydrogen produced by electrolysis, the parameter that influences the economical evaluation is the availability and the cost of renewable electricity energy. A possible option is the hydrogen production by catalytic plasma technology that has a better energy balance than electrolysis. Further investigations and development efforts are necessary to improve the performance and reduce the cost of technologies for hydrogen production. The shift from blast furnace based to electric arc furnace based steel making as part of the industry's decarbonization drive is imminent, but it is challenging in the short term, but may start in earnest by about 2025. And again, as I mentioned to you earlier, high carbon prices will force steel makers to take decisions as to whether they should invest in further reliance on blast furnaces or adopt different, potentially less polluting technologies that don't use coal. This is what I would like to submit, and I think this will give you some idea as to what processes will be followed in future and what would be the right route for us to follow with the mission of decarbonization and improving efficiency. Thank you very much. I hope it meets your requirement.
Thank you, Dr. Saraswat. Thank you so much. Those of you, the 200 odd attendees who are listening to us right now on Zoom, plus the number of attendees on YouTube, those of you who have heard Dr. Saraswat till now will well understand why I always keep mentioning that the missile man hits right on target. So he goes into the depth of the subject, and I'm sure Mr. V.R. Sharma Sahab, namaskar. And Sharma Sahab, I think you will also agree as a policy maker, Dr. Saraswat always hits the right place at the right time. And he mentioned that I think you always keep mentioning about the use of coal gasification, the need for coal gasification. And today, Dr. Saraswat conclusion, if you look at his conclusion, he said the movement from BEF, BOF to DRI module is imminent, but it will take some time. So thank you, Dr. Saraswat, once again from the core of my heart. And I just pray that you join us for many such ventures to guide us on government's policy-making decisions and the way forward in the days to come. So with that, I'll take a few questions for you, Dr. Saraswat.
Sure.
First, Mr. V.R. Sharma. Sharma Sahab, if you have a question with regard to the way forward in steelmaking route. Mr. V.R. Sharma, Managing Director, JSPL.
Yeah, thank you very much. Dr. Saab, thank you very much. You always inspire all of us. We have been making steel for many years, and the way you have enlightened us how to take care of CO2 emission, how to meet out the obligations and the commitment what Government of India has given in Paris Protocol, that by 2030 we have to reduce CO2 emission to 50% or the total carbon footprint. So this is something excellent. I don't think that there is any question in my mind, and neither anything left which can be discussed in today's topic. So you have covered so nicely. You have elaborated each and everything from blast furnace to BOF to electric arc furnace, DRI. You have also covered the two technologies, Midrex and Energy. So this was a wonderful presentation. So my sincere wishes to you and my best wishes to the entire steel industry. We are committed. We'll work hand in hand with Government of India, and all of us will try to reduce the total CO2 footprint. We are already working with the coal gasification technology, and where we use 58% of hydrogen and 28% carbon monoxide. So my only, I'll not say question, my only query from your side, which I'd like to know, that what is the future of coal gasification in this country, or you can say the brown hydrogen, converting coal into hydrogen and then utilizing hydrogen for DRI making, since we have the third largest reserves of coal. If we don't use it today, then when will we use? So this is my query from you. I think you're the right person to answer.
Dr. Saab, did you get the question from Mr. Sharma? I think he is having a connectivity issue. Dr. Saraswat, can you hear us?
Okay, as soon as Dr. Saraswat will come, we will.
Yeah, he is having a connectivity issue. So we will. Now, is he connected, or Ankit, is he connected, or Dr. Saraswat is not connected?
He's not in the, I don't see him in the panel right
now.
Yeah,
he's back. He's back.
He's back.
Dr. Saab, could you get the question from Mr. Sharma? Did you get his question, Dr. Saraswat? You are muted, Dr. Saraswat. You have to unmute yourself. Dr. Saraswat, you are muted.
Sorry, we lost connection for some time, so I could not hear what Dr. Sharma was trying to inquire. So you have to probably repeat or tell me in short what exactly I had to address, because we lost connection when he was talking.
Good afternoon, sir.
Sorry, Dr. Sharma, it happened.
Sir, you have explained everything. You have taught us what is to be done. We are committed to reduce the CO2 footprint in times to come. What I asked the question, and my query is that what is the future of coal gasification in the country? Today, we are the only company, JSPL, we are converting coal into gas, that is syngas, and syngas we are utilizing for DRI. And you have explained very well about Midrex, about Energerin. You explained everything related to BOF, blast furnace route, everything you explained. I don't think there's anything left for the other speakers to speak today. But only thing what I want to ask, what is the future of brown hydrogen, converting coal into hydrogen and hydrogen for the steel making or for any other use? So this is my question.
Dr. Sharma, I think your question can be answered in two parts. Number one, what is the future of coal gasification? As you have been involved in many of the meetings which we had on coal gasification, Government of India has given a major push for accelerating the process of coal gasification, and Coal India and the Coal Ministry are pushing this process. Yesterday only I had discussion with the Coal Secretary as to the first plant which is coming up in Dankuni for coal gasification with an intention to produce methanol there. And there are 3 more plants in the offing at different locations. I don't remember the names, but they are in different parts of the country, western part and things like that. And there again, most of them would be for, one will be for hydrogen, for example, another will be for some chemicals, and one of them could be again for methanol. So there are multiple application oriented gasification plants. So the first one, in fact, I wanted to contact you, and since you are right now facing me, there is a problem with the technology being provided by the Air Products there, where they have proposed that the gas cleaning, or sorry, gas quenching unit or gas cooling unit, instead of being in series with the gasifier, has been incorporated inside the gasifier. So we want to have an understanding what is this change which is taking place. According to them, this actually reduces the cost and things like that. So in fact, I wanted one of your experts to participate in discussion which we are holding on 17th. My office was trying to contact you. So kindly nominate somebody so that we can have a deliberation on that. So this is the status of gasification. As far as the brown hydrogen is concerned, country, particularly in the mission hydrogen, has given larger focus on the green hydrogen. In fact, Niti Aayog has very clearly recommended, MNRE has recommended the country's jump is directly towards green hydrogen. And you know what is the process of green hydrogen. But personally, as a scientist and a technocrat, I personally believe that the blue and the brown, or the blue hydrogen, is the enabler for the green hydrogen. That is the process which we have to follow. And particularly if we are looking at steel industry, and where we want to replace the natural gas and other coke and all that with the green, with the hydrogen, I thought brown/green hydrogen would, sorry, blue hydrogen will be the right approach. And that's why I highlighted in my presentation CCU and CCUS as a means to reduce the carbon dioxide emissions. So if you are going to use even brown hydrogen, if you do CCU or CCUS, automatically it becomes blue hydrogen, or the whole process becomes carbon dioxide, less carbon dioxide emitting. So this is what we should do. And I personally believe that anybody who is wanting to replace today natural gas, they should go for brown hydrogen and couple it with the CCU or CCUS, and that will give you the right amount of decarbonization. And probably if you are able to capture carbon dioxide significantly, you can convert it into very valuable chemicals like methanol, or you can convert it into even polycarbonates, or you can even convert it to carbon black, which are all very sellable items in the market. So you will have a collateral economy. So these are some of the suggestions I have. But as a country, I think they are jumping directly to the green hydrogen. That is the kind of decision which has been taken as on today.
Yeah, thank you, sir. So thank you very much.
Yeah, sir, good afternoon. It's Santosh Mundada from ArcelorMittal Nippon Steel. I still clearly remember your visit to Hajira, sir, and lot of guidance what you have given. Of course, at that time it was for defense, and we are very proud as an Indian to share that we could do a lot in that way. And whatever program was going on, that program was extremely successful for submarines. And your guidance was very valuable. So is today, sir. Honestly, this is what is going on with Steel Ministry. We had a maiden meeting last, I think 15 days back. Earlier, we had several meetings on oxygen, but now O2 has converted into CO2. And we had similar kind of sessions on this CO2. And whatever direction you have set, this is what is a thinking going on. And you have visited this HBI plant, which happens to be one of the largest in the world, DRI, HBI, and EF route. So this is what once we were thinking that these plants were cursed to us, and good that today at least it has become a kind of blessings to us, I may say. So thank you very much for your great guidance, sir, today.
I request all of you to integrate CCU and CCUS on your plants as much as you can do, because the capital inputs required for doing that are not so significantly high as compared to directly jumping to the green hydrogen inputs into the system. Because as I mentioned in my last presentation, not in this webinar earlier, present green hydrogen directly going into the steel production will boost up the cost of steel production by 20 to 30%, which will not be competitive in today's world. So one has to be very careful. And the progression to the hydrogen-based reduction of the iron ore should be done in a gradual manner through the route of brown and blue hydrogen. That is what my suggestion would be.
Absolutely right, sir. And we are also working in same CCU and CCS way, and trying to see at least in HBI plant, not directly green hydrogen, but on gray one we are working, as well as renewable energy on EF. Even in electric arc furnace, because it was earlier appeared to be very, very difficult, but now we have done some kind of modeling and we can see that RE can be also used even in electric arc furnaces.
True, true.
I want to ask one from Dr. Saraswat.
Yes, sir.
Dr. Saraswat, let me introduce Mr. Deepak Bhatnagar. He is
I met him earlier. Yes, yes.
Yeah, he knows me. Dr. Saraswat, you have been hearing, and I would like to know your guidance on the future of use of pellets in the Indian blast furnaces, because I'm finding there is a lot of controversy between pellets and sinter, and what is the government view actually, and more important is how do we beneficiate medium and low grade ore to produce pellets, because that's our national asset. So what is your thinking, sir? This has been going on in a controversial way. Thank you,
Mr. Bhatnagar, my views on this, I already shared with you when we met last time. My view personally is that the pellet manufacturing is the answer for reducing our energy consumption on sintering and things like that, which are basically required. So we should do it. But the problem is the disconnect between the steel producers and the pellet manufacturers. Because you two gentlemen are working, gentlemen means the two groups are working on two different islands. There is no communication, there is no interaction. So if you work in a synergistic mode, the pellet manufacturing will get the right boost, and the blast furnace people will get immensely benefited in terms of energy saving, as well as there will be a reduction in cost. This is my analysis. But there are issues of what we call as the center-based profit generation. So once we work into that, then you run into a problem. We should look at the whole system of steel making and then allow each center to make profit adequately. That is what we should do. Presently, one is only looking at his own profit and not worried about what should be with the pellet fellow, and pellet fellow is worried about what should be the iron ore producer, because fines have to be collected, fines have to be transported. So if the pellet manufacturing is not located very close to the mine, you run into problems of cost of transportation and so on. Now, this is an issue which you people should sit together and resolve, because they are today possible to be resolved in a very, very amicable manner. Ultimately, in the interest of improving efficiency, reducing costs, and reducing CO2 emissions, and reducing the and improving the efficiency of the system. That is the way I would look at, and this should be put as an integrated activity, not in isolation.
Thank you, sir. Thank you. Thank you very much.
Thank you, Mr. Bhatnagar. One last question I'll take. Saxena Saab, you have a question?
Good evening, Dr. Saraswat. Good evening, Sharma Saab. Good evening, Mr. Sir.
Mr. Saxena, yeah, Mr. Saxena is the Director Operations of Vizag Steel Plant, Rashtriya Ispat Nigam Limited. Yeah.
I want to congratulate Vizag Steel Plant for giving immense support during the oxygen problem in the pandemic. They were one of the major feeders for the South Indian grid, I suppose.
Yeah.
Welcome, sir.
In fact, all the steel companies, I want to congratulate them for the immense work which they did for the oxygen scarcity during the second wave.
Thank you very much.
Sir, so your presentation was, hello, am I audible?
Yeah, you are audible. Please go ahead.
So your presentation was really comprehensive and revised the whole metallurgy and the scenario in the Indian steel industry. And as you rightly said, that pellet manufacturers and the steel producers, they are at different platforms, and there's still a lot of logistics things and synchronization yet to be done. And yes, pellet use of pellet is definitely going to improve the techno-economics of steel making process. But is it that somewhere we are going to promote those pellet manufacturers so that a particular part of iron ore which is left otherwise can be utilized? I mean, are we thinking of giving some encouragement to those pellet manufacturers?
Yes. I think you should sit with Mr. Bhatnagar. We had a very detailed discussion on this part of pellet manufacturing and mining operators, how to take care of the fines, how to take care of the middlings and things like that, and how to reduce the cost of transportation, because they were all factors which were responsible for pellets not being cost effective for the blast furnace operators. So this was the reason, and we did an immense study on this, and we found that there are ways and means. There was some taxation issue also. And we said that inverted taxation system should be
royalty is a problem.
Royalty issue. So we have recommended those measures. I suppose the Steel Ministry was working on it, and in the revised steel policy, some of them have been incorporated also, but not all of them. So still the issue is not completely solved. But I think if we push it, it can be solved, in my opinion. Mr. Bhatnagar also lost his steam in between. He has not come back to us with the same vigor in which he came earlier. If we, I think, work together, we can make pellet manufacturing as one of the very profitable and good for the steel manufacturing.
Thank you, sir. We'll do it. Thank you, sir.
Thank you.
Dr. Saraswat, we just have a couple of questions from the audience. I will just quickly read them out.
Sure.
So we have a question from Mr. ACR Das. He says, Dr. Saraswat, your presentation was very enlightening. Congratulations for your wonderful presentation. But as you know, Indian steel producers are lagging behind in terms of energy consumption and CO2 emission. We have limited scrap or NG to help reduce CO2. Coal gasification, syngas route also results in large CO2 unless used with CCS or CCU. So what is your prescription for Indian steel producers in longer term perspective? And is government proposing any guideline or strategy for India towards net zero emission by 2050? Along the same lines, we have another question from Mr. Vaibhav Pokharna. He says CCUs at present is very costly process and there are not many consumers of captured CO2. Are there any policy steps in this direction to make CCUs market competitive? So if you could briefly answer these questions.
Mr.
Yeah,
Asia,
I think, sorry, you wanted to say something?
Dr. Sarwat, I just wanted to mention Mr. Asia Das was earlier Industrial Advisor in Ministry of Steel. So he's an ex-man from Ministry of Steel.
Okay,
That's
okay,
all.
okay. See, as far as the method of using coal to coal gas to replace the NG is one of the methods which I mentioned in my talk also. Is a very good method because ultimately the same carbon monoxide can be made use of for the reduction of the steel. So that is one thing. It will reduce actually what is happening due to coal gasification to a certain extent. The carbon dioxide, it will remain almost the same what you are getting otherwise, because after reduction anyway you will get some CO2 which is coming out of the furnace. So that will happen. So but CO2 has to be captured and utilized. Now I tend to give you some figures that the capital cost for adding any CO2 capture facility and utilization facility is less than a single digit number, which is what is there. Whereas if you go for elaborate hydrogen business and all that, the amount required is much large. The CCU technologies are well-established technologies. They can be tried out today. It's just a question that India has not done this. Third one is, the benefit is not being actually given to the customer because in India, we have not started costing the carbon dioxide. The moment we start giving carbon credits for carbon dioxide saving, you will find that the cost of carbon dioxide saving becomes very high. Like in Western Europe and other places, there is a, for every 50 tons of carbon dioxide, if you save, you get almost so many dollars of, I forgot the number now, so many dollars of benefits. If you start valuing that, you will find your CCU becomes very, very lucrative. So if that will, and Niti Aayog, now we are coming up with a plan, studies already launched today, that CCU and CCUS, how do we make it more cost effective by way of reduced capital and also incentivizing the whole process by carbon credit, and finally bringing some of the very important chemicals which can be used, which can be produced using the carbon dioxide and things like that. So I'm not directly going into carbon dioxide sequestration, which appears to be a very difficult process today. And but certainly two processes like extended oil recovery, EOR as we call, using the CO2, and another one is the coal-based methane, where again CO2 can be made use of, are very possible uses for sequestering the carbon dioxide. Unfortunately, in all these areas, India has not made much progress, but other countries, technology is available. If we shake hands with them and we can incorporate in our plants also. So don't worry, we are working in this line to bring CCU in a big way as a focus as far as decarbonization is concerned.
Thank you, Dr. Saraswat. Any question from our European participants? Either Mr. Plazona, who is from Danieli, or from Cristiano from Polwart, or Dr. Andreas Martke. Any questions from our European participants? Danieli, Polwart, or Primetals, any question from any of these technology providers?
Yes, maybe I can have a question.
Yes, Cristiano, please. Cristiano, please introduce yourself, and in a few lines, if you can explain what Polwart does as a part of SMS Group.
Yes, I'm part of SMS Group. I'm the responsible of the Center of Competence Iron Technology, which incorporates blast furnace and DRI production through Midrex. We are very active in India as technology supplier in the iron making field as Polwart. I'm speaking from Italy. I'm interested to understand whether in India this carbon capture from iron and steel making could find application in producing urea, which is a fertilizer. And I think India is a big producer of urea. I think this route of carbon capture plus urea production is something India should have evaluated. Is this so, or is there any plan to develop this route?
Yeah, we would like to certainly make use of this. Urea is one of on our cards. That is CO2 to urea. That is one on card. CO2 to methanol is on our cards. CO2 to polycarbonates is the card. CO2 to carbon black is on the card. So these are some of the products which are going to fetch lucrative returns and also possible to be done at a very reasonable cost.
Okay, thank you.
Thank you, Cristiano. Thank you, Dr. Saraswat. Please bear with us for another few minutes so that Mr. Sharma can, highlight his views. Over to you, Sharma Sahab. Mr. V.R. Sharma, Managing Director and CEO of JSPL, Jindal Steel and Power Limited. Over to you, Mr. Sharma.
Yeah, thank you, Nirmala. Thank you. And thank you, Dr. Saraswat ji. And thank you, my friends, ladies and gentlemen. It's a great conference today through webinar. And the topic chosen by Mr. Nirmala is excellent: BF, BOF, and electric arc furnaces. And it happened so that today, fortunately, Prime Minister of India, respected Shri Narendra Modi ji, he has also declared the scrap-EAF policy for the vehicles. So this policy has come into force, and I'm sure more and more scrap-based electric arc furnaces will be installed in the country in times to come to meet out the challenge and to meet out the demand of the universe as to how to reduce CO2 from the steel plants. So today, put together, on an average, Indian steel industry is generating 2.5 ton of CO2 per ton of crude steel, and reaching to a target of 1.85 ton per ton or 1.9 ton per ton will definitely be a very challenging task. And unless we switch over from conventional blast furnace routes to electric arc furnaces routes, conventional sintering route to the pellet route, and conventional steel making through BF, BOF to DRI and then electric arc furnaces, this will be really very, very tough, very, very difficult. So we have to have a mix of BOF shop, mix of electric arc furnaces, and then only we can meet out such targets. Otherwise, the time may come that in 2028 or 2030, like China is thinking today to shut down some of the blast furnaces, then we may have to shut down the blast furnaces at that time. In the meantime, the technology providers are here, SMS Group, that is Polworth. Then we have the Denley team also here. They have the company Denley Chorus. Then Prime Metal, everybody is listening at this particular message. Many of the steel plants in India, they are still working to put up the new blast furnaces in India. At least 7 or 8 blast furnaces are likely to come in next 3 years' time. So now the time has come to to finalize the technology based on hydrogen injection. So whatever maximum hydrogen injection we can do, we should try to do. And how to generate hydrogen, yes, that is also a big question mark. Though Ministry of Steel feels that the green hydrogen, that is from the renewable energy like solar or wind energy, that should be used to produce hydrogen through water electrolysis method. But the chances of such energy availability are at remote today because unless government passes the bill of free flow of electricity from one grid to another grid without charging any levies, duties, or the charge or the grid charges basically, or the wheeling charges. So this will not be possible. So I think Government of India will have to work out very positively that anybody who is having a plant, solar plant or wind plant in the western part of India and the steel plant in the eastern part of India, so whatever energy we generate over there in the western part or we buy from somebody, then at the same energy with minus the losses, that should be available at the same price to the steel mills, to produce hydrogen. It is very difficult to transport hydrogen, but of course we can transport electricity easier than transporting hydrogen. The another request what we are making to Government of India, that we have more than 350 billion ton of coal. So today the entire power sector, more than 70% of the power generation is through the thermal power plants. So all of these thermal power plants located somewhere in eastern part of the country or western part of the country or up north in Punjab, Haryana, Jammu and Kashmir or in Rajasthan, they should be relocated to the pit heads. Once they are relocated to pit heads, they will be in a position to manage the fly ash. And secondly, the time will come when thermal power plants will be converted or will be phased out, and finally we'll have syngas based combined cycle power plants. If we have the combined cycle power plant based on synthesis gas, that is coal gas, that will give much better efficiency than the normal Rankine cycle thermal power plants. So thermal power plants today are running in between 26% efficiency to 32% efficiency. Each 1% of efficiency increase reduces carbon footprint by 2%, CO2 emission by 2%. So if we put up the turbine-based combined cycle power plants based on syngas, then the efficiency can be as high as 56% in combined cycle route. And that means we can definitely save at least 24 to 25% in terms of efficiency, and which will definitely reduce CO2 emission by 50% for the same power generation. So it is not only steel, but power sector, cement sector will also have to cooperate the country. And finally, all of us together, we can meet out the declaration made by Honorable Prime Minister in Paris Protocol 5 years back. So the another area what we must see that everybody and most of us, we always speak on green hydrogen, we always speak on hydrogen-based economy, but it is a little far away from the reality as of now. So the best solution is, yes, we can inject some 5 to 7% hydrogen, maybe 10% hydrogen, and this is what the companies like Polworth, Prime Metal, Denali Chorus, or any other company in the world, maybe some of the Japanese companies, they have to demonstrate that how much hydrogen they can absorb in a blast furnace, and what will be the charge mix, what will be the coal mix, what will be the coke mix, whether PCI, what will the impact on PCI, and so on. So once those technologies are matured at affordable price, then only we can think for the hydrogen injection. But I personally feel that we must try to convert coal into syngas and syngas to hydrogen, and that hydrogen we should try to use for the injection purposes. The second is coal to syngas, syngas to DRI, and then DRI to steel through electric arc furnaces. There's another answer. Then similarly, coal to syngas, and then syngas to power generation through the gas-based power plant, or I would say combined cycle power plants. That's the next solution in front of us. We have to choose that which technology, who is going to implement, and how can we get support from Government of India. We have more than 350 billion ton of coal. If we don't use today, then we'll never use it. I don't mean that we create CO2 and we create problems for the nation. No, it should not. We should try to use it in most environmental friendly manners. So thank you very much. That's all from my side. I'm available for any kind of question if anybody is having. Thank you.
Thank you, Sharma Sahab. Thank you once again. I'm sure our panelists will have some questions for Mr. V.R. Sharma as well. Let me take a few questions right now. Is there any question which anyone would like to ask? Alessandro Martinez from Danieli. You must be happy that today Mr. V.K. Saraswat, member of Niti Aayog, has asked, specifically mentioned about Energiron.
Yes, thank you. Thanks.
And since you are one of the implementing agencies for Energiron, along with Tenova. So would you like to ask any question with regard to the implementation of energy iron technology in India, either to Mr. Sharma or to our honorable member of Niti Aayog, Dr. V.K. Saraswat?
Yes, I have a question for Mr. Sharma. In particular, we know that for all other
Your voice is not clear. Sorry, your voice is not clear. Can
you hear me now?
It's better.
Okay. How do you see, Mr. Sharma, the future of the thermal reduction that is able to use additional fuels, like, for example, hydrogen, not only hydrogen, coke-oven gases or syngases in India, where we know that natural gas is not such an abundant resource for the industry. So do you think having the flexibility to use also, for example, syngas or coke-oven gas can be seen as an advantage?
Thank you very much. Though your voice was not very clear, but I could guess the question. Yes, we are using coke-oven gas also. We are mixing with the syngas, but we want to use it more. Basically, today we are using about 30% or about 35%. But we want that we should use at least 60% coke-oven gas. Finally, we had some issues with methane, and we are trying to address this particular issue. Hopefully, we will be successful in making it to more than 50% or more than 60% in times to come. But now, yes, you're right. We are using syngas as well as coke-oven gas for the DRI plant.
Yeah, Ravi, I can see after one Haryanvi, another Haryanvi is waiting to ask a question. So over to you, Mr. Ravi Singh. Your comments, initial comments, because you have seen both the worlds. You have worked for Tata Steel. Now you are the CEO of Sulb in Bahrain. So what is the scenario vis-a-vis Bahrain and India? So Mr. Ravi Singh, CEO of Sulb. And
thank you, Nirmalya. I think I was very appreciative of the presentation by Dr. Saraswat. It was very enlightening. Excellent coverage of all aspects of the industry, challenges in India and globally. But I had one small query, if Dr. Saraswat may like to enlighten on this subject. We, of course, use gas-based DRI in Bahrain, and we have been quite successful. We already have plans available for converting to 100% hydrogen as and when it is required. So conversion is not a problem, but as Dr. Saraswat rightly pointed out, the cost is exorbitant in terms of the generation of hydrogen. So, and there the basic cost is of the cost of the solar cells, because only two ways, either wind. Today, wind is cheaper to generate hydrogen, green hydrogen, rather than solar power. Although by 2050, solar power will probably be much cheaper. And by that time, green hydrogen will be at the cost of natural gas as available in the Middle East. I'm not talking of as available in India. So India will probably cross that, that line much earlier. So the key thing is the conversion in India for solar power, manufacturing solar cells, converting the entire economic structure into solar power-based energy. And India is a big country, you know. So once you convert that, you'll be a driver for the whole world. So is there any government plans to move in that direction?
Yeah, you must have read about our mission solar. By 2022, we want to have 175 gigawatts of solar energy. And our plan by 2030 is to reach 450 gigawatts of solar energy. That is our plan, which is with the intention to have our total grid input of solar energy into the electrical grid reaching more than 50%. That is the kind of plan we have, that by 2030 we should decarbonize the electric grid by about 50%. You will know that if you really want to achieve the real, what we call as the kind of 1.5 degrees centigrade kind of a thing for the global warming, the modelings which have been done by International Energy Agency very clearly says that unless the grid becomes 90% decarbonized, the cost of hydrogen will not be, green hydrogen will not be affordable. That is the kind of prediction which has been made by the International Energy Agency. This is not my data. I am just quoting from that. But even if it is not correct and has a kind of robustness or credibility in the data of 20-30%, to reach that level of greening of the grid is one of the major requirements for reaching the green hydrogen economy. So what you have said is right. 2050 is the target which most of the nations have made, including America, Europe, and all that. In India, we are trying to see that we can have solar energy in a dedicated manner to produce green hydrogen using the kind of exercise we have. Unfortunately, even today, while we are jumping into the solar energy scenario in a big way, our dependence for solar energy inputs, aggregates, is totally again from the outside world, particularly from China, where we get the kind of solar cells and things like that. So we are making major efforts in setting up now solar power plant, solar aggregate manufacturing facilities. And if that happens, probably we will have a faster approach to reaching the green hydrogen situation. I expect that by 2035, we will have at least 30% of the greening of the grid. And that will be available for various applications like steel making or the cement manufacturing or others. But I think you heard me earlier. My approach and my suggestion to the steel industry is, as you mentioned, instead of waiting for the green hydrogen to happen, I think what Dr. Sharma mentioned is the right route. We should use coal because India has huge reserve of coal. We should generate syngas and syngas to hydrogen or syngas directly into the furnace, where you can use carbon monoxide and hydrogen in certain proportion for the reduction of the iron ore into the required, this one should be our route. And if it is integrated with the power for power production and other applications with the integrated gasification and combined cycle, the economics turns out to be very, very favorable. So if we do these studies and integrate, at least in the new plants which are going to come, as Dr. Sharma mentioned, there are about 7 to 8 new blast furnace plants which are being planned. I think these are the plants which we should immediately start looking at: integrated gasification, use of more and more syngas into the system, and so on. So this is the kind of a scenario that should be applied. Certainly greening will be there, but it is a bit away from the present scenario for next 10 to 15 years.
Thank you, Dr. Saraswat. I absolutely am with you, because I cannot see scrap giving enough steel for the world today.
No, it cannot. It cannot. 5%,
and it will probably remain the same. My own calculations show even by 2050, the world will not have more than 35-40% of scrap-based steel making, of course, on a much bigger denominator. But so you will have to use iron ore-based. DRI is a good process, but DRI-based iron ore is very costly, and it is scarce. It is less than 100 million tons in the whole world today's production. So blast furnaces are not going anywhere, and we will have to, as you rightly pointed out, and Mr. Sharma pointed out, we will have to find some ways of greening the blast furnaces as a way forward.
Yeah, I agree with you.
Thank you, Dr. Saraswat.
Thank you, Ravi. Thank you, Dr. Saraswat. We will now move on to our next speaker, Mr. A.K. Saxena, Director Operations of Vizag Steel Plant, Rashtriya Ispat Nigam Limited, followed by Ravi Singh, CEO of Sul Bahrain, followed by Dr. Siddharth Mishra from Tata Steel BSL. So let's
Mr. Mukherjee, can I take leave if you don't mind? I have another assignment.
Yes, sir. Thank you so much. Thanks for showing us the way forward, and hope to see you soon in our next conference on decarbonization and hydrogen in steelmaking. That is later next month. So we will keep in touch with you and expect your blessings and guidance. Thank you so much.
Thank you very much, and all the best for the rest of the seminar. Bye.
Thank you, sir. Thanks from the core of my heart.
Yeah.
With that, let's move on to Mr. A.K. Saxena, Director Operations, Vizag Steel Plant. Saxena ji, the floor is yours.
Good evening, sir. I think much has been talked about the structure, steel industry, the percentages of both the routes. And yes, as it has emerged so early, that BF and BOF route is not going to go anywhere because of economies and scale of operation, the volumes. But of course, the other route also has its own advantages. And yes, we are eager. I mean, what technology providers today who are attending this webinar, what they have on the platter. But if you talk of the experimentation, I think enough of experimentation has been done in our country, starting from Corex to your DRI coal-based and DRI gas-based. But end of the day, not saying that people have not adopted, but most of the users shifted to the conventional BF, BOF route, and which has rightly been pointed out in the presentation of Dr. Saraswat, that it is not only it requires lower capex, as well as the cost of production is also quite low. But what V6 has said, that yes, greening of steel in the current BF, BOF route is also another challenge. Or there is there can be some hybrid technology that you use 50% of this process and the rest of the other process. I don't know whether that kind of hybriding is there on the platter. So, but I feel that BF is, I mean, it appears to be still beyond challenge. Yes, but MSMEs and certain. If we think of 300 million ton and think of logistics going a little beyond the scope of a webinar, then perhaps these MSMEs producing through DRI-EAF route in certain localized area, yes, they serve the purpose, but whether the steel will be at the proper cost. So the cost of running the plant, cost of capex, as well as CO2 emissions, and then greening of steel making procedure. These are the questions, and these are being discussed at a very correct time when almost most of us are in the process of thinking what should be the way forward for next 150 million tons of steel in India. So what is the right technology? What is the how to select the technology? So it is. I expect this webinar is going to be very fruitful to all the technology providers, the steel manufacturers, to everyone. It will be going to be an enlightening session, and it had a very good start by Dr. Saraswat. So that's all from my side. I'm eagerly waiting for the technology providers to give us to show the kaleidoscope what is there or not. Thank you, Nirmal.
Thank you, Saxena ji. Thank you so much. And as Mr. Saraswat rightly mentioned, it's really a great job that Vizag Steel did for the nation in providing oxygen during the time of need to the entire southern grid, as he rightly mentioned. So, and in spite of all obstacles, your plant has done exceptionally well. And as the head of the plant, I must compliment your efforts, which you did to put everything in place in spite of the challenges you had from the trade unions and all that. And as we all know, Vizag Steel Plant is already up for disinvestment. So the challenges are huge, and I'm sure Vizag Steel Plant, like always, will be one of the front runners in this country, and in the days ahead, it will remain a flag bearer of Indian steel industry. With that, my special thanks to you, Saxena ji. I'll move on
Thank you,
to.
Nirmala ji, and team is really working well, and they
Yes.
are on the way of producing. I mean, again, I expect the record figures.
It has it has a very young workforce, so there is a lot we can expect from Vizag Steel Plant in the days ahead. So with that, I'll move on to.
Can I just ask a question from Mr. Saxena? One sentence.
Yes, sir. Yes, sir.
Please.
सब ऐसा है, आपको हम लोग को आदेश मिल गया है from Dr. Saraswat. मेरी एक रिक्वेस्ट है कि let us have a one-to-one meeting on Zoom or anything which you prefer. And if you can send me a mail when it is convenient, I will call all my members. My one sentence to you is, sir, Vizag has to take a lead in use of pellet in blast furnace. That's all. My request.
I mean, I love that part of technology, and yes, I'll be in touch with you, and
So
we'll see what.
I don't want to disturb everybody, but let us have a one-to-one this thing. Just send me a
Definitely, sir,
mail at
definitely.
our PMA. I don't know your email. If you can
Yes,
send me, I'll be glad.
I'll get your email. No issues.
I will
Okay.
share you. I will.
We'll be in touch.
I will share your email both with either of you. So सक्सेना जी को आपका email भी मैं दे दूंगा.
Thank
So
you,
you will-
Nirmalya.
Thank you, Bhattacharya ji.
You are Nirmalya. You are also a very good marriage broker.
I earn my salary, but
Marriage means
yeah, marriage is get together between two families. So
Yes.
that is my job. That is
what
my job.
Dr. Saraswat said between the blast furnace people and pellet people.
And pellet manufacturers. Right. sir.
Yes.
Exactly. So that's my job. I earn my salary by bringing people together. So that's a part of my job.
Thank you. Thank you.
Thank you, Bhattacharya ji. With that, I'll move on to our next speaker, my good friend Ravi. And Mr. Santosh Mundada also knows him because Ravi was the head of, the Hypermart business when he was in SR Steel. So a very good friend and someone whom I admire a lot, I respect a lot. So over to you, Mr. Ravi Singh, CEO, Sul, Bahrain.
Thank you, Nirmalya. Is my slide visible?
Yes, of course.
Oh, perfect. So I just put together some slides, but they're actually irrelevant now, given the excellent cover which has already been given to the topic by Dr. Saraswat as well as Mr. Sharma. But maybe these are all data available in public domain. There's a lot of bad mouthing on the blast furnace and BOF route currently. And we have to understand that one of the major problems that the world is facing, we as a species, as a human species is facing, is the global warming. And currently almost 50 billion tons of greenhouse gases are emitted by the world. These are 2015 figures. It's difficult to do these studies, but this is an excellent study which shows that almost 73% of the greenhouse gas emission comes from energy sector. And out of that, 24% is from industry, with 7.2 to 9% is the contribution of iron and steel. So we are one of the largest contributors as a single industry or a single sector to the global warming. The others being, of course, automobile, which is very easy to understand. It's almost 16%. Buildings is 17.5%. And then also standard agriculture itself causes global warming. If you look at from 1900 to 2015, I think this is an excellent summary of how much each process route used by steel industry from 1900 onward. Some of them have now become obsolete, but this is the amount of greenhouse gas emission which each of the routes has emitted into the atmosphere between 1900 to 2015. So obviously, a blast furnace rules the roost at almost 58 gigatons. And it is important to understand that we sometimes overlook the global warming which happens in mining area, which even before the iron ore reaches the steel plant, which is also quite significant. So overall, DRI is at 1.2 gigawatts to blast furnace at 58 gigawatts. Part of that is because the production of DRI has been much less compared to the amount of production which goes through blast furnace route. It's important to keep these things in perspective because when we are understanding, when we are talking about this subject. Steel industry has not been silent. It has been doing a good job. It has been reducing the greenhouse gas intensity ever from 1900 onwards. Unfortunately, from 1990 onwards, there's been a plateau. And that is partly because China and India started increasing the steel production, and the favored route was the blast furnace because that is obviously the cheapest way of making steel, although it was not so good on the greenhouse gas. Otherwise, if you really look at it, globally, EU, North America, Latin America, these guys have much lower carbon intensity footprint compared to India and China. And these are the guys who will really be driving policy shift globally towards more and more less carbon intensive steel making. So you will have already, EU has brought in the border tax. It is going to carbon tax was always there from around 30 euros per ton today. Expect that to go up to 75 euros, even 100 euros. EU is going to drive. They call it the Brussels effect. They will be the benchmark for the best technology, lowest carbon emitting technology, and being the benchmark, they will drive the whole world towards this side. Otherwise, forget the big markets of America and EU. So what really is the issue? How do we really look at it? We need to reduce global warming, and it's an existential issue. It is not an issue it's not a technical issue. If the temperature goes up as it is going, very soon species will start dying. Very soon food production is going to start getting affected, because beyond a certain temperature, fruits or the pollination, etc., just doesn't work. So this is a very serious issue which the mankind is facing, and it has a limited amount of time. You know the latest IPC, I don't need to get into that. Excluding China, EAF is almost already 50% of steel production. So there is the world is not going to give much of will not be very indulgent to somebody wanting to now produce steel using the other routes. And EAF, as has been discussed, is anyway cheaper, lower carbon intensive than blast furnace and BOF. Mostly the problem happens in the iron side, not in the steel making side. But the problem is that two problems. Number one, the amount of investment which the steel industry would need to make to shift to green technology. As per a fast market study, it's about $1 trillion. And if you include the carbon side, it's another around $340 billion over there. So that's a humongous amount of investment which is required to shift from the current technology to a green technology, which has also been raised. The other problem is when we look at EAF, DRI steelmaking, the problem with the DRI technology is that the amount of iron ore which is suitable for DRI pellets is very limited globally. Australian ore is not suitable for making DRI pellets. So you only have some mines of Vale, Anglo, and maybe much smaller quantities in Fortescue, etc., which can be used for DRI pellet manufacturing. The global DRI footprint today is about 100 million tons. And out of that, a good quantity is India, which is coal-based, which is as bad as any other steel-making route. So coal-based DRI is not really the way forward. It has to be gas-based DRI. And that's where the crisis really is. You don't have the iron ore to shift the whole world towards DRI. Already you would have seen Normally, DRI pellet premiums used to be about $30, $25. This year, it's already currently at $70 per ton. So if you compare to iron ore pellets, you have DRI pellets with a premium of $70. And Santosh and I know very well from our other steel industry experience, what is the cost of pellet making? It is not $70 per ton. We know that very well. So that is a major problem of trying to shift to DRI. The other problem, of course, is availability of gas. Now, there is a good news actually, because if you can shift from current mid-rex technology, which is the world leader at about 65% of the global, 65-70% global DRI plants are mid-rex. The next is, of course, HYL, and energy iron is just about starting. The DRI technology really runs on, needs a little bit of carbon dioxide, carbon monoxide in the reaction to take it forward. And it runs on natural gas. So it can be shifted to 100% hydrogen. But the cost of that hydrogen is going to be very high. It is not so much the cost of changing the steel plant. The mid-rex plant can very easily shift to a hydrogen plant. There are certain changes required. There are certain changes in the water systems, cooling water systems, etc., and in certain other systems, but it can change. But the problem is that the cost of hydrogen, even in Middle East, where we get natural gas about $3.754 a ton per MMBTU, the cost of hydrogen would be multiple times of that, maybe 10 times of that. And that has a major impact on the commercial viability of hydrogen-based DRI. Of course, that will keep coming down. So, but however, given the fact that it is an issue of existence of the human race, I think you will see the policy shifts will start happening. The government policy has to first shift. And once the government policy comes in with certain taxes on carbon, etc., the industry will be forced to look at technical process developments to align themselves with the requirement or close down. And then you will see commercial rollouts. The global scrap is also not a solution, because global scrap currently may be about 700 million tons, will go to 1,000 million tons by 2030, 1.3 million tons by 2050. But given the way the steel is expected to keep increasing it in requirement, in consumption, it will still remain between 35 to 40% of the global metallic available. So that is not going to be a solution. And electric arc furnaces need scrap-based. So that they will have certain advantages, but you will have to look at some way of making the blast furnaces more and more green. This is a cost of hydrogen, which I said there's some good news and some bad news. The bad news is today the cost of hydrogen is very high. Over a period of time, it keeps coming down as more and more world moves towards either wind-based or solar power-based steel making, electricity generation. You'll find the cost of technology will keep coming down. Let us not forget that in 1910, there were auto CEOs who commented, why would anybody want to buy a car? The horse carriage so much more, right? Dirty was much cheaper and worked very well. So we are really at that horse carriage moment today, even in the steel industry. We may look at that hydrogen is very, very costly. Not why should anybody shift to hydrogen, but I think that is a direction in which the technology is going to shift. It's our choice whether we want to keep sitting on the road or we move forward. We have already in Seoul done our shift we have already done our plans on shifting to green hydrogen. In case the Europe border tax, etc., really come into play, we are prepared to make the change. It will take about a year or so. It takes about 9 months to get the technology, the equipment, and then one can shift. There are problems in shifting to 100% hydrogen. What is the problem? Number one problem is that there is no carbon in the DRI. When you make DRI, one of the key ingredients look for is carbon. because that gives you the chemical energy in the electric arc stage, electric arc furnace stage. There is going to be no carbon in a green DRI, and therefore at the electric arc furnace stage, you will have to add carbon to get the steel. And adding carbon and electric arc furnace stage is less efficient than having it in the form of cementite from the DRI itself. So that's a problem. And then of course, you will need every steel plant. Steel plants have been reducing their land footprint per million tons of production. But once you go towards hydrogen-based, solar power-based, one will again have to start looking at large tracts of land to set up the solar panels and to then use that for electrolysis and creating that gas. But I think overall, we still have, there may be certain steps in between, but that is the direction that we will have to go. Thank you so much, Nirmalya.
Thank you, Ravi. Thanks for once again showing us the writing on the wall. As you rightly mentioned, what looks very difficult, very expensive. At one point of time, we remember our mobile phones were so very expensive. Yes. Today, anyone would think of having multiple mobiles, not just one. So that's what technology does in course of time. So I'm happy that you pointed this out. And if you see the changes which are happening in Europe on a day-to-day basis, the technology providers are working, I would say, extra hours. I am sure, our colleagues in Polward, Danelli, Primetals, they know very well that this is a challenge for them to undertake, is to reduce the cost of producing hydrogen. So that's what is happening. And we will soon see a different cost structure altogether in the days to come. And this is bound to happen. So thank you, Ravi, once again for always keeping my request. And I'm not going to let you go after today's webinar. We have the next one on decarbonization, where I want you to be there. And there is one on coated products where I also want you to be there. So I will keep a track of wherever you are, and I'll get hold of you. Thank you once again from the core of my heart, Ravi, for being there. We will now move on to Mr. Siddharth Mishra, Head of Operations Steelmaking at Tata Steel BSL. And I would request Mr. Mishra to take the floor. Mr. Mishra, thank you and warm welcome to you.
Thank you, Nirmalya ji.
And let me thank TVN, Mr. Narendran, for nominating your name. So TVN actually had sent across your name. So I'm thankful to Tata Steel for recommending Dr. Siddharth Mishra. So, Dr. Mishra, the floor is yours.
Could you please confirm if my slide is visible?
Absolutely. Absolutely clear. Yeah.
Thank you. Thank you once again. And I think given what our predecessors, preceding speakers have spoken, Dr. Saraswat, Mr. Ravi, and Mr. V.R. Sharma, it seems like a repeat, and I would seek your, excuse for being redundant in the topic. I guess sustainability has been the flavor of the day. And just put my 2 cents in there, few slides of sustainability comparison of BOF versus the DRI, scrap, and the EAF steelmaking route. Just giving some figures. So top blast furnace uses around 1,300 to 1,400 kgs of iron ore, around 800 kgs of coal, some fluxes and scrap depending on where you are in the world. EAF on the other end is primarily scrap based with some iron ore, again, based on where you are, some coal around 150 kgs, limestone, and a lot of energy. When we talk about maximum scrap, obviously that helps us in terms of CO2 mitigation. So 30% is the max which we can go in a BOF as opposed to 100% in an EAF. And if we talk about the 2 steelmaking process routes, world average is around 73% BOF as opposed to 27%, although that is slightly swayed to around 44 to 56% in Indian scenario. So that's kind of a little different. The other output or the byproduct, I would say, from steelmaking other than steel is the slag, which is again on a sustainability aspect. The more slag you generate, the more you have to recycle, landfill, or do some value extraction out of it. So a lot of slag produced from the BOF side, around 400 kg as opposed to just 170 kgs per ton of crude steel from EAF. So a lot has been said on these two processes as far as the CO2 emissions is concerned. The left side is the BOF side, BOF, BF process route, and the right side is on the EAF, DRI, or hot metal can be one of the charges. Electricity doesn't come cheap, and then we need to factor out the CO2 which is getting emitted when in producing the electricity which is being used in the electric arc furnace. So just by changing from the BF, BOF to EAF production route, the impact on the climate actually does not shy itself away. Just to give you a few statistics, this is readily available on World Steel Association's website. Global CO2 intensity is around 2.3 tons of CO2 per tons of crude steel, and the top 5 best performers are giving us around 1.7 tons of CO2 per tons of crude steel. If you look at the gas-based DRI EAF production route, that comes down to around 1.5 tons. And again, the top 5 are just giving 1.25 tons. So that's still, a long way to go to where we look for net neutrality in terms of reaching our targets of zero CO2 emissions. EAF alone is actually the better route, better option with around 0.6 tons of CO2 per tons of crude steel. And if you look at the top 5 performance, it's reduced to half at around 0.3. But still, the production is heavily swayed towards the BF, BOF, and therein also BF, blast furnace route, contributes to around 85% of the total CO2. So whatever work needs to be done is to be heavily concentrated on the blast furnace side, but then that does not leave the steel makers off the hook. We also look at 15% of the CO2 produced. So scrap is something which we can utilize to our benefit. What are the levers which we can utilize for the BF, BOF route in terms of reducing CO2? Avoiding carbon direct, use less carbon, more of hydrogen, and that has been a major discussion point in most of my preceding discussions today. You use hydrogen as a reluctant, different shades of hydrogen. So that obviously time will tell which is more economical and how to go about it, but facilitating hydrogen bearing gases like CO2, natural gas or syngas, as Mr. Sharma was saying. Raw material quality improvement, again, it has a bearing on the blast furnace efficiency improvement using a better prepared FE burden in terms of sinter or pellet. We are primarily moving towards the pellet side. So Mr. Deepak Gupta may be happy to hear that. We have lower ash coals for better coke making, higher quality coke, lower blast furnace slag rate, again having a bearing on the blast furnace efficiency. Low alumina ore, that's been a bane as far as Indian ores are concerned. Low coke moisture via the coke dry quenching unit. Most of our coke production in Jamshedpur Tata Steel Works is through the CDQ route in Tata Steel PSL, where I'm currently placed. We have 2 coke ovens. One of them is with CDQ and the other one is still the normal quenching process. Then we have a scheme in place to convert it to CDQ. So that will give us some better efficiency in terms of getting energy extracted out of it. Use of hot briquetted iron blast furnaces, that again reduces the energy demand. CO2 capture, CCU, CCUS, there's been a major discussion point. So we need to find suitable points for CO2 storage located adjacent to subsurface storage reservoirs. Substitution of fossil carbon with renewable biomass, that again has been discussed by the previous speakers. And again, as I said, for the steel makers, we need to try to see how best and how much we can utilize as far as the green scrap is concerned. But as Mr. Ravi was saying, there's only so much available in the world. So ultimately, we'll have to find some other ways of extracting iron units, maybe through hydrogen-based DRI making. A DRI EAF route, obviously metallization of DRI is a big factor. The high degree of metallization gives us better yield. Lower yield obviously looks for a higher energy consumption, and therefore the entire process becomes all the more unattractive. Carbon in DRI, more than 1% is preferred. Obviously, there are reasons, because it gives us a good source of energy. There is this carbon void, which gives better quality in terms of nitrogen removal and such like things. But then a higher FEO obviously also requires some amount of carbon to offset it. Higher flux consumption, CO and MgO consumption increases with higher gang in the DRI. The energy requirement requires around 100 to 200 additional kilowatt hour per ton of electrical power when we use DRI as compared to scrap. And coal-based DRI, which has been the primary source of DRI in Indian scenario, has a lot of additional gangue, not as much carbon, so the energy as well as the gangue are adverse when we talk about this source of DRI. Hydrogen DRI-EAF, that's one other technology which has been heavily debated and coming to the forefront. Here the CO2 intensity decreases to around 0.1 to 0.25 tons of CO2, depending on how much carbon integration we want to do in that DRI, again, as I said, for energy reasons. So green hydrogen can be a low cost, at low cost would be a necessary requirement for substituting natural gas for gas-based DRI production. Key enablers would be cheap energy or cheap electricity, high electrolyzer capacities. And we need to look at the cost of DRI production via natural gas, because today it's around $12 per million BTUs. This I'm just providing a brief layout of our Tata Steel BSL facility, where we have both blast furnace, BF, as well as DRI and Konark. We have one of the only 4 operating Konark furnaces in the world. So we get a real flavor of what the CO2 production is. We are running at around 2.7 tons per a ton of crude steel. That's kind of high, but then there are some legacy issues, and there are some not so efficient processes which we are trying to take care of. And as far as just a diversion, DRI, if we start getting it from a greener source, that would be good. And we have made some leaps in terms of trying DRI in our BOF processes, and we have had good success. There's a lot of fines which could be a deterrent for using DRI. It can impact recovery, it can have lower yield, and also clog the GCP. Flame shooting can be an issue, and there's a risk of handling when it comes in contact with moisture. You could have excessive fines. So we've tried to do some screening, get some good, better quality lump DRI, and we've tried to put it in our BOFs. And it has given us good unit. Although the yield is not as good as the scrap, but obviously it's a cheap source of iron. And if it can be produced in a more carbon or CO2 friendly way, then I think this can be a good replacement. We have not seen any impact on the refractory. The GCP has been fairly well positioned. Savings, as I said, is obviously there based on the cost, where we are in the cost curve. And on the quality front also, not much of a nitrogen impact has been seen. And with the Konark process, cost obviously is in control. So those are a few of the ideas and points I wanted to mention. That's all I'd like to share. Thank you.
Yeah, thank you very much, Dr. Mishra. So do we have any questions for Dr. Siddharth Mishra?
Yeah, Dr. Mishra, Gaurav here. I have only one question. You have shown that you are screening the GRI to plus 12 millimeter and you are using in BOF. So what do you do with the minus 12 millimeter? And what is the screening, the percentage fines generation?
Gaurav sir, good evening.
Good evening.
Yeah, so that's a good question. So plus 12, we tried to put it, in fact, the bigger the better, obviously with the metallization. So the bigger one, we try to put in the BOF. The lower one, we briquette. So it's a cold briquetted iron, which is again fed into the Konark. So Konark, we are using around 40% of our total charges DRI with CBI combination. And I would say around 25 to 28% is DRI, and balance is this cold briquetted iron, which is the fines which are bonded.
Okay, thank you. Thank you, Mr. Ji. Thank you.
Sure.
So I think we have one more question from Dr. ACR, so Mr. ACR Das, who is in the attendees. Mr. Das, if you could unmute yourself and ask your question.
Hello, Dr. Siddharth.
Good evening, sir. Good evening.
Good evening. Namaskar. I just wanted to know, in the context of global warming and the topic which Nirmala has taken up today is so relevant, are you thinking for any, say, gas-based DRI EAF route in future?
Yes, sir.
That is one of the routes wherein you can reduce drastically, if not net zero, CO2 emission.
Yes, sir. And we are seriously contemplating that, although availability of natural gas in our area in Angul is still a challenge, but that has been a serious consideration. And we are looking very seriously in converting our coal-based DRI vehicles into gas-based. Obviously, that's a bigger, longer-term project, but that's been under serious consideration.
Oh, thank you. Thank you so much.
Sure. Thank you, sir.
So a question from Mr. Shamul Kumar Sinha. What is the percentage of HM, DRI and scrap in the charge mix at EAF?
So we have a Konark furnace, and as I said earlier, the charge mix would be around 55 to 60% of hot metal, and balance would be DRI. Scrap is very little. We used to use around 18% scrap, but that has been shifted to DRI now. So balance around 40% is DRI and coal briquetted iron combination.
Thank you, Dr. Mishra, for your wonderful presentation and for answering all the questions. Moving on to our next panelist, we have Mr. Santosh Mundhada, Executive Director, Hazira, ArcelorMittal Nippon Steel, India. Over to you, Mr. Mundhada.
Yeah, good afternoon, rather good evening to you all. And thanks, Mr. Mukherjee, Senior and Junior, for organizing this webinar. And it's really, it was a great interaction. And I take some advantage also of having so many speakers already spoken earlier. So there is not much new to add, but I can always say, basically, you all know that ArcelorMittal Nippon Steel, this AMNS Hazira, happens to be the largest single location hot DRI and cold DRI producer almost in the world, and the journey started much ahead. Of course, whatever issues we face in the past, basically because of these gas supplies and all that, of course, today also these gas prices are not very favorable for this steel making, but yes, we can say that we are contributing in trying to reduce the carbon footprint, and going forward, of course, a lot of innovative ideas are going to get implemented in this route. The modules which were almost abandoned are all producing to its full capacity. And I can say that even last month, when there was a kind of even rainy season, and generally we don't produce that much, but our all HBI production was the highest among all, and it's going on. And basically, with, as I said, that we have been pioneer in this one and adopting this technology of HBI, DRI. Now HBI, we only call HBI plant, but we try not to make the HBI and try to maximize of DRI, and in DRI also maximize the hot DRI. That is where you can save the power. A lot of innovation has gone in that direction, and we are very successfully producing even from the modules as aged as like 30 years old, but with very good efficiency, I may say, in terms of power as well as gas. And in this same these modules, we are now working on how to use whatever external hydrogen we get, either in gray form or green form. Like in green, it would be difficult, but we are already studied, and all these modules can be adapted to the hydrogen. Even matter of fact, around 80 to 90% of natural gas can get replaced by the hydrogen if hydrogen is available. As has been said by earlier speakers and concurred by Dr. Saraswat also, that hydrogen is not affordable right now, I may say. This gas-based technology, this DRI route itself is a costlier route if you see compared to BF, BOF. And even when we had a interaction with Steel Ministry last time, we told them collectively that country has to look at rationalizing the natural gas prices, because that will become one enabler if we say that we have to go for more of DRI EF route. Yes, this can be done, and it can really help a lot in reducing the carbon footprint, not only just I'm saying because of the hydrogen injection in that, but even like a hot DRI you use and then you use renewable power to make for the melting in EF, which is possible. And these are all different steps we are taking right now. Very actively we are deliberating all these subjects and moving in that direction. Of course, another thing versus BF, BOF route, the quality of iron ore or quality of rather I may say pellets and iron also, it has to be better than BF route. You need better Fe, and for that beneficiation is required. Many a times the pellet plants, they face problem of land, because for beneficiation you require quite a bit of land. We are also having issues. So these are all enablers. If they go, I think this route can be sustainable. Something with gas prices, something thinking about hydrogen and optimization of process. And of course, in this route, you can use scrap. We know that scrap is not available, but with these scrapping policies and all that, it will little bit ease than what it is today. Apart from that, even in BF route, we are working, rather we have taken successfully these trials and all that on natural gas injection to reduce the coke consumption, and that will also give some kind of carbon footprint. It will help in that direction. Another thing is that we are of the opinion that process gas, whatever gas is generated in a process, whether it is blast furnace gas or any other process gas, and coke oven gas, which will be there in future because we are also going for it. All these gases should be maximum utilized in a process than producing a power, and that would also help in a carbon footprint easing out that. So we have now with us our parent companies. ArcelorMittal is there, Nippon Steel is there, and both of these parent companies, they are also marching ahead on this CO2 reduction. Very actively they are going ahead. So over the period, we as a AMNS will also have some leverage there, and we are very much committed that between economic scenario and whatever technology evolves over the period, whatever new things will get explored or innovated, we will be always going with it, and we are fully committed for it. So thanks once again for this organizing this webinar on this subject. As I said earlier, we had on oxygen, and on oxygen front also you have seen our film and all that. We always consider steel as a service sector than a manufacturing sector. Whatever we could do, we thought that we never imagine the oxygen from steel plant will go to the go for saving the lives of the people, and we could build our first gaseous oxygen based hospital, and that hospital you all might be knowing. In 72 hours, we set up a 250-bed hospital, which was expanded to 1,000 later on. And that concept was multiplied by all. And I hope third wave should not demand it. It should be at low key. So far, we are all, at least in Gujarat, we see cases are very less. We hope, we pray that it remains like this. So thanks a lot for this. I think you are on mute, Ankit.
Yeah. Thank you very much, Mr. Mundada. And your talk was very brief and concise and to the point. I just have one question for you. So since you were talking about the carbon footprint of steelmaking routes, so with the prices of solar energy coming down, what do you think are the chances of adapting solar energy for producing electricity for secondary steelmaking routes?
Yeah, we are very actively considering it. Matter of fact, we are going to tie up very soon a big chunk of our power through renewable energy. We have already done some study. And as I said that normally we see melting shops, EAFs, they are a power guzzler. And the if you see power demand curve or melting cycles, they are very erratic. You need a peak power of something which is almost twice when it is in a refining stage and all that. So powering this from the renewable energy is a challenge, but we could do some work in that direction. And you will see soon our furnaces will be powered by RE.
Thank you. Thank you very much for answering the question, Mr. Mundada. And we have a couple of more questions for you in the chat and in the Q&A section. So just to save time, if you could answer them directly in the Q&A section, then we can move on to the next presenter. You can see one question in the chat from Mr. Bhushan Bobre, and another in the Q&A section from Mr. ACR Das.
Sure.
Thank you so much, Mr. Mundada. So now I would like to move on to our next presenter. We have Mr. A.K. Bhatta. He is the Executive Director, Projects, Steel Authority of India Limited, Bhilai Steel Plant. Mr. Bhatta, are you there?
Yes, thank you. Am I audible to all of you?
Yes, we can hear you.
Okay, thank you. Thank you, Mr. Mukherjee, Mr. Nirmalaya Mukherjee. At the outset, let me congratulate the Steel and Metallurgy publication in having organized this webinar on a very apt subject, the BF BOF route vis-a-vis the Scrap-EAF routes of steel making. And lot of things have been said by our esteemed panelists earlier, Dr. Saraswat and Mr. Sharma, and also by Mr. Ravi. I think I do not have many things to add as far as from Steel Authority of India Limited. We are now expanding for the next phase of modernization. Presently, we have a saleable steel capacity of 20 million ton, and by 2030, the entire country would go to 300 million ton per annum, and we plan to increase our crude steel capacity to 50 million ton. That is nearly 1/5 of the market. However, being a public sector unit, we have till now we have been concentrating on the BF, BOF route of steel making. The DRI or the Scrap-EAF route of steel making is still unexplored in our SAIL steel plants. But this particular modernization, we have made a vision document also for 2030, which is also giving us the BF and BOF route of steel making, including pelletization. But now when we see that the China is closing down their blast furnaces, and the Ministry of Environment and the local state Environmental Conservation Board, they are also tightening up, and the norms are getting very stringent and stringent. I think we need to look into the aspect of the hot metal DRI's EAF route of steel making. However, in this regard, I'll just tell that we have got large land banks is available. Nearly 50,000 acres of land bank is available in all the steel plants. That is Burnpur, Durgapur, Rourkela, Bokaro, and Bhilai. At Bhilai, if you see that we have already stopped at the old steel making route, that is the open hearth, twin hearth furnaces and the blooming mill. And that we have already stopped. We have gone for the entire BOF CCS route of steel making. We have that particular old mills to be removed. And in place of those mills, we would be planning to have these new route of steel making. But it's very difficult to find technology providers and consultants in this regard. I take this opportunity to invite good consultants and good technology providers who can come down and see what is our product mix, indicative product mix. And based on that, the land bank which is available with us, how best we can put the new route of steel making, which definitely would reduce our carbon footprints. There is a lot of other things which I need to talk, but this is what we had envisaged in our vision 2030 at Bhilai steel plant per se. I just would like to tell that we would be putting a 5,580 meter square blast furnace for a 4.7 million ton per annum hot metal, and augmenting our steel capacity to another 5 million ton. Presently, we are 7 million ton plant. Another 5 million, that makes 12 million ton plant with 200 ton BOF and one caster and a thin slab caster. And our special products would be HR, HRPO, HRPGL coils, sheets, and special quality bars. But now when this particular aspect of carbon footprint is coming, we would be definitely giving much thought on reducing the carbon footprint by taking this particular route, the EAF route of steel making. So this is one thing which we are anxiously looking for. We need good consultants. We do not have good consultant to suggest us how to close these mills, old mills, and in place of these old mills, these land bank can be aptly used to make to replace and to make use of the best of the land bank which is available. Once again, thank you for the entire panelists. It's a very apt subject, and I could even learn many things from this particular webinar. I once again thank the organizers for that. Thank you very much.
Thank you very much. I think we have a question from Mr. Anil Anand.
Yeah, Bhatta Sahab, good evening to you. And
good evening.
I'm very delighted to hear the expansion plans of Bhilai Steel Plant. And as we have been your partners for many years, we'd like to further continue and in this process of product mix and at the what kind of plant you should have, what kind of a blast furnace, looking into your this raw material specification, what kind of ore you have. I think this colleague and our technology specialist, Mr. Cristiano, will be submitting a paper on that. And together with my team from the steel making and also from the mills, I would like to organize in the next weeks or 2 weeks time a session with your team in Bhilai so that we can deliberate and we can also offer consultancy and then take it forward with you, sir.
That's very right. Thank you so much. In fact, we are going to set up a 1 million ton pellet plant at our Delhi mines because it has a lot of large amount of silica and alumina gangue contents, which is actually hurting our new blast furnace. That is blast furnace number 8.
Yes.
In fact, yesterday I was at NMDC Hyderabad lab in order to understand how the mineralogical properties are there, because and how would our Delhi minerals, Delhi iron ore fines, which we are also taking the tailings of the Hitkasa tailings, which is having as low as 45 to 50% of iron. So how can we use it and make use of that waste product and convert it into pellets? So there also I would be requiring your consultancy for that.
Sir, we'll be at your disposal, and I will organize all the specialists together, and we would like to present a case study for you, sir.
Thank you.
Thank you, sir. Thank you.
Thank you, Mr. Bhatta, for your presentation. So before we move on to the next speaker, I would just like to mention that we have had over 200 attendees in Zoom today, and with a couple hundred more probably watching the live streams. So thank you all for joining us today, and a big thanks to all our sponsors, because without them this event would not have been possible. So sorry, something came up on my screen. Yeah, so with that, I would like to move on to the next speaker, Mr. Prabhat Kumar Ghorui, Senior Vice President, Technology and Excellence, JSW Steel Limited. So over to you, Mr. Ghorui.
Yeah, good evening, Mr. Ankit, and good evening to all. Ankit, will you share my presentation, or I will do that?
So I have allowed to share the screen, so you can try to share it yourself, but otherwise I can also.
Okay, I'll get it.
Otherwise, I also.
Is it visible?
Yes,
is it visible?
Yes.
Yeah, very good. Okay. Mr. Ankit, actually, before me, a lot of speakers, I think, almost covered everything. So probably I have not much to speak, but I have made a presentation, so I'll definitely run through, and I'll stress upon some of the areas where probably things are not covered, but rest of the things I'll run through. So to begin with, I'll just cover a brief about the world steel and Indian steel scenario, and then a comparison, and then what is the trend of the pellet, DRI, and usage point. So this part, all of us know that how the steel is growing in worldwide, and we have also grown to the 111 million tons, and we have a mammoth target of 300 million tons by 2030. Even optimistically, if we consider that this 300 is not going to happen, maybe 200, 250, whatever happens, but that itself is a big target in front of us. Now, if you have to grow, then how do you grow? The question is whether it is the BOF route or the DRI-EAF route. So that's the big question in front of us. If you look at the present distribution of the steel making in India, so today we are around 43 to 44% through BOF route, and remaining 56% is through DRI-EAF or the scrap-based EAF or induction furnace. And it is expected that this BOF will continue to grow till maybe 2030 or 2035. to meet the steel policy target of 300 million tons, and thereafter probably it may decline, and by 2050 it may be close to 25 to 30%. So immediately I don't see that the BOF steel production route is going to, rather will dominate our DRI-EAF route. So if the sustainability point of view, this is already been discussed by many. So of course the BOF route is less emitting compared to the DRI coal-based, but of course the DRI gas-based and EAF route is definitely it is less compared to the BOF route. So what are the challenges in front of us as far as BOF is concerned? As far as the BOF concern is, the emission is definitely one challenge from the sinter making as well as the coke making, and dependency of the fossil fuel, that is the fuel rate, and the scarcity of coking coal in India, and the CO2, overall CO2 emission, ultimately the resulted CO2 emission. Over and above, if we see the slag rate in Indian condition, the quality of iron ore is deteriorating day by day. And especially at Vijayanagar, we are located at a place where plenty of iron ore is available. But however, the Mother Earth is so biased, the high grade iron ore availability is absolutely low. So our present average Fe is around 57, 58. So you can imagine what is the alumina and silica, MNO, everything is there. So that is a big challenge in front of us. And as far as this, DRI Scrap-EAF route, the question was discussed earlier also, the high grade availability of iron ore. That's a big issue, especially not only the Belarus sector, but across the country. Overall high grade availability, even if we consider 62 plus Fe, is hardly 90 to 20%. So 80% is of medium grade. So that's the big question mark in front of us to convert into pellet and then to DRI and then convert into liquid steel through the EAF route. Of course, higher cost of production, which is already discussed, and the poor availability of scrap and price volatility. So that is also a challenge. So even if we target to increase the scrap, the availability of scrap itself is a concern. And then the lack of gas network across the country. So today, even if we think of, to replace this amount of PCI coal by the natural gas, but to bring the gas to our site, that itself is a big task for us. And dependency of fossil fuel and the volume challenge. What I foresee is the volume challenge, because today through blast furnace I can produce 4.5 million tons, 5 million tons, 5.5 million tons from a single module. Whereas DRI, I don't know whether that much of bigger capacity is available. So you need enough, land and all these things. Of course, CO2 emission is much lower compared to this BOF route. So even if we see that with this all this challenge, also the pellet production capacity is continuously growing. So from 2016, from 80 million tons, that's gone to 90 million tons, and production also has gone up from 47 million tons to 69 million tons. So that's a big jump. Capacity wise, if we see, the capacity wise has not increased. Capacity has increased by, from 2016 to 2020, it has increased by 9 million tons. But the production has increased enormously. So that means utilization of the pellet making has increased. Now, if we see the DRI also very similar, DRI production is also increasing day by day. So now if I summarize that what is really going to happen in future. So as I said that BOF route is definitely going to be dominating next 10, 15 years down the line. But keeping in mind the sustainability, we need to do a lot of work on reducing the fuel rate. So that means increasing the PCI, reduce the coke, replace the PCI with green natural gas or hydrogen, and improve the operation efficiency of BOF. And finally, the carbon capturing and utilization, which is already spoken by many speakers. And this shift from DRI to EAF route will happen, but the question is the facilities for more volume and quality of pellet production. So that's a big challenge. Even from 58 grades to make a 63 plus pellet is a big challenge. There is amount of tailing we're going to lose. The amount of iron ore required to convert it to pellet is a big task in front of us. And of course, the larger model to reach to 250-300 million tons. Gas network across the country, that has to happen to bring down the further CO2 emission. Otherwise, if it is coal-based, does not make any sense. And even if we have to increase the scrap, so Sarma Aji was telling about this, the PM has already declared the scrap policy of the vehicle. So I don't know how much is going to bring the scrap availability. And this cheaper availability of the renewable energy, that is also spoken. So for me, BOF is going to dominate in down the line, 10 to 15 years time. Thereafter, if I consider the BOF life of 20 to 25 years, that means beyond 50 only the EF, DRI EF route is going to dominate, not dominate, rather will start dominating over BF and BOF route. So that's all from my side. Thank you. Thank you all.
Thank you. Thank you very much, Mr. Gurui. So do we have any questions from the panel? Any questions for Mr. Gurui? Okay, so I just wanted to touch upon one small point that you mentioned about the availability of high quality ores. So what do you think is the solution in the short term to deal with that problem?
If you see today, we are doing a lot of preferential mining is happening. So we are more focused on high grade today, leaving aside the medium grade. I think we need to be a little compromising with the blending and some amount of restriction of the high grade mining and some amount of incentive for the medium grade and low grade mining. That will extend the life, and at the same time you can upgrade the medium grade to a moderate level of high grade, and if you do beneficiation, probably you will be able to reach to 60 to 63 plus and convert into pellet. So that is my suggestion.
Okay, so so basically to ensure sustainable availability of high grade ores in the long term, this can be done.
Yeah.
Okay, one question we have from Mr. ACR Das. Mr. ACR Das, if you could unmute yourself and ask the question.
Gurui sir.
Sir, good evening.
Good evening. You have given, of course, very good presentation on the general viewpoint of the future and made a statement that blast furnace is going to stay. Yes, I think it is the viewpoint for the future. But what is your, GSW's specific plan to reduce CO2 and become greener and greener in years to come? Thank you.
Yes. Tomorrow, actually, we have a strategy meet. Our chairman is here today. We are looking for a bigger blast furnace. Of course, considering the higher top pressure to, for better gas utilization, reduce the coke rate, reduce the slag rate by incorporating, beneficiation, more and more beneficiation, and then, increasing the higher blast temperature. So today we are at 1100, 1150. So we are looking for 1300 degrees centigrade. So we are targeting overall fuel rate of 440 to 450 kg per ton. That is the target. So from the present level of 525.
Yeah, so that is basically reducing the CO2 to some extent, and but that is not going to sustain the future operations, sir.
Of course, that's why presently we are targeting by 2030 from 2.5 to 1.9. Okay. So thereafter, as I said, slowly we have to bring it down to the Of course, not zero, but at least competitive with the world standard.
Okay, thank you, sir.
Thank you, sir.
Thank you, Mr. Guri, for answering the questions. And I see that there are a couple of more questions in the chat. So if you could address them in the chat, that would be great.
Yeah. Okay.
And
Thank you.
also, I saw that Mr. Mundada has also answered the questions in the chat. So thank you, Mr. Mundada. And also thanks to ArcelorMittal Nippon Steel India for being a sponsor for this event. And I would also like to thank all our sponsors once again: Jindal Steel and Power, ArcelorMittal Nippon Steel, and Primetals Technologies, our silver sponsors, and our steel sponsors: Polwart, SMS Group, Danieli, Calderis, Maxis Motion, and our refractory partner RHI Magnesita for supporting this event. So speaking of sponsors, our next speaker is from Primetals Technologies. We have Mr. Shibu K. John, Vice President, Strategy and Business Development for the upstream business, Primetals Technologies. Over to you, Mr. John.
Yes, good afternoon to all of you. Can you see the screen?
Yes, we can see.
Okay, good. So, okay, good. Thanks a lot. I think it was a very, very interesting presentation, and thanks Steel and Metallurgy for organizing this presentation. My name is Shubhu John. I am based in Austria, Linz. I'm responsible for the strategy and business development. And this topic for us is very, very important as a technology supplier. We have heard from all the customers and the industry what's the requirement. So what I would try to do today is the solutions what we as a technology supplier provides for this problem of how to make the industry more decarbonized. So I will just go through maybe the next one. Just give me a second. I'm not able to move my. There seems to be some problem.
Maybe you could try to click on the screen once and see if you can.
Yeah, it's okay. Can you see now? Is it visible? The screen is visible?
Yes, we can see.
Yes,
Okay, good. So before I start, it's a lot has been talked about it, but just to give you a global perspective on the CO2 emission. So if you remove the CO2 related to agriculture land use, so we are talking about 36 gigaton of CO2 globally, of which India generates around 2.65 gigaton of CO2. And as we know that there's a lot of commitment made by a host of countries to be carbon neutral by 2050 and China by 2060. India's position is not known, but India is committed to reduce its carbon intensity by 33 to 35%. We believe this will be super achieved, and today we heard it will be probably 50% the emission reduction. So when we come to this and look at the overall picture of the steel industry as such, so we can see that globally we have seen that the steel was around 1.8 gigatons, or 1,800 million tons. So this is likely to grow at a very, very slow 0.3% CAGR. This is based on the SDS scenario. The SDS is a sustainable development scenario where we are trying to limit the CO2 emission by the temperature rise by 2 degrees centigrade. So if you take this sustainable development scenario, we see that it's growing by 0.3%. Today, globally, the EAF route is around 28% and BOF is 70%, predominantly by China. Future, this is going to entirely change in the opposite direction, with EAF and DR route constituting almost 57% and balance coming from the blast furnace BOF route. So if you look at the emission globally, almost double the emission of steel is done from the blast furnace, from the steel route, the direct emission and the indirect emission. So we are talking about 3.7 gigatons of emission from the steel industry. If you look at both the emissions, we are talking about more than 10% of the global CO2 emission, which is emitted by the steel industry. And looking at this sustainable development scenario, this has to come down to less than 1.6 gigaton, which is a 55% drop in the emission required globally. If you look at the Indian scenario, as we know that India produced 111 million tons in 2019. And although there's a target to produce 300 million tons by 2030, but looking at all the resource efficiency and assuming India's GDP growth at a slower rate, so we believe maybe at around 368, 370 million tons. So still it's a 4% CAGR growth. And in this case, today, India is already producing on the EAF, DR, basically coal-based DR, with 56% coming from the coal-based and the electric arc furnace, induction furnaces, and balance from the BF route. Future, we see that this percentage more or less remaining the same in spite of the huge growth. But the blast furnace BF route, if you see here, also need to look at carbon capture and storage solutions. So there is a small modification which is being done on the blast furnace or the smelting route in the future. If you look at the carbon intensity from the steel, so in 2019, the total carbon intensity scope 1 and 2 was 2.5 million tons, 2.5 tons per gigaton of steel, per ton of steel. And this has to come down to almost 1.1 tons, ton of CO2 per ton of steel produced, if we have to match the global requirement of 55% reduction. So this is a tall order. And as we know that the next target for 2030 is set at 2 tons of CO2, but to reach 1.1 is a tall target. Okay, so if you look at the Indian scenario, as we have heard today, India has a lot of plus points and it has got a lot of pain points. If you look at the plus points, it certainly is endowed with a lot of reserves, 28 million tons of iron ore reserves, pellet capacity of 70 million tons. They're good, knowledgeable people, have experienced people. The big driver being, again, the low cost of electricity. We see from the recent auctions, the prices have come down substantially to $25 to $30 per megawatt hour. The renewable energy is going to go up by 450 gigawatt from 90 gigawatt now. And the freewheeling of renewable energy and the other reduction in the cost of the electricity gives a great potential for hydrogen in the future. And there's a growing demand for steel. Today, it's around 111 million ton. Even we take a very, very pessimist scenario, we're talking of 370 million ton, coupled with a lot of activity is going to be on e-mobility and demand from customers, specifically the auto customers who will demand low CO2 emitted steel. So I think Indian steel industry has to think how to make low CO2 steel. If you look at the pain points, of course, the Indian ore is a low quality ore with a high alumina silica. We need to find a solution for this. High natural gas prices, the availability is not there. Lack of carbon capture and storage. So there has to be a solution in terms of infrastructure generation for the carbon capture storage and the pipeline. So India also has a huge today import bill on the coking coal, more than 10 billion ton. The policies, incentives for CO2 reductions are still not in place, unlike in Europe. For example, in Europe, we have a EU ETS system. Today, the CO2 prices in Europe are around 55 euros. So this is still lacking. So if you look at, again, a global picture, the Indian picture of how the CO2 emission from the different production routes are looking like. So what we try to analyze is in 2019, what was the emission intensity from the grid? So India's grid emission intensity is around 700 gram of CO2 per kilowatt hour. That's the amount of CO2 which is generated from the power which is produced from different sources. In the future, if we expect this to go down to 80, what is the impact? So we try to plot if it's a BOF, even if the intensity is going down, that means more and more renewable energy coming, even with the best available technologies today, which is available, we can reduce from 2 tons to 1.9 tons. So this is the emission for all the scope. When I talk about this emission, the scope 1, 2, and 3, all the emission put together. The smelting DRI route is comparatively slightly less, but still it is high emitted. The natural gas EAF route is less when the intensity is less, but the problem would be again, where is the availability, where is the natural gas? So these solutions on the left-hand side, which I say the gray, need certainly a carbon capture utilization storage solution. And what we see on the right-hand side is the H2DR scrap-based and green H2. Interestingly, today there's a lot of H2, but today if you talk about producing H2 from the grid, which is around 700 gram of CO2, we are talking about a carbon intensity more than the blast furnace, because the CO2 which is generated from the electricity is too high for the hydrogen production. So this is not a viable option. The only viable option is when the renewable energy is completely green, or it is a very, very low emissions. If you look at when the green intensity becomes 80 gram, so then the CO2 emission is reduced. And when it becomes absolutely zero, that means the green renewable energy in green form is used for hydrogen, then we can bring down to less than 200. So we have basically two scenarios here. One is the scenario on the existing blast furnace route, which has to do optimization and all the process improvements, and also look at putting up a carbon capture, storage, utilization solution in the future. The second scenario is to look at a scrap-based solution, which is today good and the future also good, but there are restrictions in terms of scrap quality, in terms of the steel grade which can be produced, but certainly can be combined with a DR plant to mix the DR and scrap to produce the right quality of steel, like it is now done in US and other countries. So there are basically two specific solutions, the two specific requirements to be done. So what we see is there's stepwise transformation. We need to look at what we can do today, currently, in the midterm and the long term. So we tried to highlight, say, five key solutions. The first one is the blast furnace optimization, or the BOF route optimization. Still, the Indian, some of the blast furnaces BOF still can bring in efficiency in terms of improvements in the process. So we believe this is the first step. The second step would be increase in the scrap rate in the basic oxygen furnace by preheating the scrap, by using dual flow burners and many other solutions which are available. The second step would be to pre-melt the scrap in the integrated plant and then mix it with the hot metal in the BOF. So the scrap, whatever is available, is pre-melted, so we can reduce the CO2 emission by 30%. The third step would be to, instead of putting a BOF today, put a EAF fusion, which takes basically a higher hot metal today, but could be converted to take scrap as available in the future. So this could, could reduce by around 40%. The fourth step would be a two-step process. This is specifically looking at the grade of ore which is available in India. So our idea of this process is to keep the processes from the converter onwards exactly the same as it is, but make hot metal from a DRI and a melter route to produce hot metal. So this can take low grade. I'll come to this topic again, but this could reduce by around 85%. The last solution is for the integrated route, the long-term solution of carbon capture utilization and carbon capture and storage. So we from Primetals, what are the technology solutions we are providing? There's a host of technology solutions for the process improvements. I do not want to go into each and every of the solutions. If anybody is interested, please get in touch with us. But just to give maybe a couple of examples, on the agglomeration side, if you use a selective waste gas recirculation, we can reduce 7 to 10% of the CO2 on the sintering side just by one of the measures. There are many other measures. Combined, it could give around 15 to 20%. Coming to the blast furnace, a lot today was talked about the hydrogen injection. Certainly, this will reduce the CO2 emission up to 20%, but it also has an effect on the PCI and other things which has to be looked into, but certainly it has an implication. COG injection is also an easier thing to do, which can bring down the emission by 5 to 7%. So there are a lot of other measures like HBI scrap feeding and many other measures. So this could give around 20 to 40%. Looking at the basic oxygen furnace, so I will just pick up maybe one dual flow post-combustion lancer. So this will enable you to increase your scrap rate. Let's say you have 16% you can scrap rate now, you can increase this to up to 30% with the proper level of automation and introducing this lens, which can bring down the emission by 4%. So there's a lot of technology, small improvements which are possible on the near term, which the steel industry should look at what is best for them. And if they're interested, we are ready to support them and partner with them. So looking at the second step is, I would say it's more a electric arc furnace based route, but this is something very specific which Primetals have developed. It is called a EAF quantum, where the scrap is preheated before it is melted, which enables us to produce steel at a very, very low power consumption of less than 310 kilowatt of ton. There are right now 14 plants under operation and under construction worldwide, many in China. So this would be an interesting option for India to start with, to melt the scrap and then add it to the BOF, and subsequently also for the existing some of the plants which wanted to use scrap as such. The second solution would be EAF fusion. So this is something that in the initial phase, it is operating with 80% hot metal and then slowly converting this into 100% operation. So based on the trend and the scrap availability, this could be implemented today if there are expansion plans that the converter shop is equipped with a EAF, which is allowing to take higher amount of hot metal. So this also gives you a flexibility for the future. So coming to the midterm and the long-term solution, I would focus on two topics which was discussed today in detail, but what are the solutions as a technology supplier we are providing to the market? The first one is the DRI-EAF solution. So we are the licensee of Midrex, have built a number of plants worldwide. So if you look at the Midrex plant, it is flexible to use natural gas and hydrogen as a fuel. Depending on the, in India, we have examples of coal gasification, Corex gas usage, natural gas usage. So all the fuel flexibility is available. And when hydrogen is available, it could be injected into the natural gas-based plant as and when available up to 30% without modification. And then we can also do further, but maybe change the reformer more into a heater. Today, the renewable energy cost in India, I was looking at the auction price last week, it is less than $30. Last year, it was $25 per megawatt hour. With this amount of electric power, renewable energy cost, the cost of hydrogen is going to be quite reasonable compared to the cost of hydrogen in other parts of the world. We think India is in a very, very unique position in terms of its renewable ambitions, in terms of its green ambitions, the solar potential, the renewable potential in India. So hydrogen could really kick off in the long term. And although it is still an expensive process compared to the blast furnace or the coal-based DR route, but there will be certain markets like the auto markets which are willing to pay that premium for that extra price of steel produced through decarbonized route. So we are ready to provide this technology. The technology is available today. Just to, coming back to the issue of I have heard today a lot on the quality of the ore in India. So when we look at the quality of the ore, it has a high silica, low Fe. So what we say is a two-step process. Today, Mr. Ravi spoke about the SULP DR plant, which is using a DR grade pellet. It's a fact that there is not much of DR pellets available in the world. So we try to look at what are the solutions we can bring to the market to cater to this bigger availability of lower grade ore, let's say less than 65% ore. So we talk about a two-step process. The two-step process is a DR plant, and then we are using it in a melter. So this is slightly different from the EAF. So the difference being in the EAF, we are doing the melting, reduction, and refining. On a melter, we are only doing the smelting and the reduction, and the refining is done on the converter. So which allows us to have a low FeO content and a high yield. The electricity will be slightly higher than the conventional EAF, but the yield is high, and it's a better operation when compared to the EAF for a low grade ore. So we believe this solution would be relevant for the Indian market. So we are in the process of developing the technology for this melter, mainly for the low grade ore. So this could be an interesting option for the future for steel companies who are looking to decarbonize in the future, but still utilizing all the downstream facilities from the converter onwards, keeping it same without no change. So you don't have to do your certification of steel in the future. So this is an example of the plant we recently have contracted. This is in Russia. It's a 2 million ton HBI plant. This plant can take up to 30% hydrogen. So this similar plant could be of interest in India, using natural gas, syngas, or any type of hydrocarbon in any form, whether it is coal gasification. Use the green hydrogen which is produced, blend it, and can produce low carbon metallics. It could be also an option for the global steel companies in India. All of you have now set up outside India to also look at putting up plan. For example, if I see JSPL, they have a plan in Angul, in Shadi. They could also think of putting up in Shadi than taking the HBI to Angul to reduce their carbon footprint. So there is a natural gas available, so it could fit in very well. They should also look at how to combine synergies or the strengths available in other places. So this is just to give you an example. So coming to the carbon capture, I think this also needs to be considered. Today, there's not much talk, but we from Primetals, we are owned by MHI, and MHI is the leader in carbon capture. There are more than 15 references of high capacity carbon capture plant in the world. The picture which you see on the right is a carbon capture plant in a power plant in Texas, which is capturing almost 5,000 tons per day of CO2. If you compare a blast furnace of 2.5, it would require a carbon capture of similar size. So in terms of technology readiness, the technology is available. So if you look at the blast furnace, if you can even capture 50% of the CO2 from the BF top gas, the CO2 can be reduced by around half, 750 kg of CO2 can be reduced, but on a hot metal. We think this could be interesting as the time comes, but certainly the government has to think about enabling it by proper infrastructure, by generation of certain hubs for capturing the CO2s, the storage facility. But this could be one of the pathways for the integrated route to move forward for decarbonization. And as we know that the Indian blast furnaces are quite young, so we believe this will stay, but there has to be a solution, and this possibly is one of the solutions to bring in deep decarbonization. So coming to the utilization, so we've been also working with Lancetech. We are a partner of Lancetech. So this is a plan which is implemented for under implementation for ArcelorMittal in Belgium, in Ghent. So this is basically using the CO to ferment it to produce ethanol. So this could be also a co-fermentation could be done for CO and CO2 to produce ethanol by mixing hydrogen. So this is also in terms of usage. So we are, along with the partners, ready to do the usage part in certain of the application. So these are some of the technologies which we think is relevant in the future. And as Primetals, we think that the pressure to reduce CO2 is there. There will be a lot of pressure from the investors, from the financiers, from the customers, specifically the customers, the global automakers would certainly demand low CO2 steel. So the steel companies steel makers should gear up to meet that. The export would become tough, as you know that EU is now going to implement carbon border tax. So there would be other countries also following. So there will be a lot of global pressure. And we think this process has to be done. There is no way that we can overcome, considering the impact which is having on the climate and the impact which the steel brings on the climate. And we from Primetals are ready to offer the solution. We can provide the process optimization, the pre-mill process, the EAF fusion, the carbon capture utilization and storage, DRI-EAF with our partner Midrex, and also in the future to produce a hot metal through a DR smelting route. So these are some of our thoughts which I would like to present today, and I look forward to hear from you any of the questions.
Yeah, so thank you so much, Mr. Shibuke John. Do we have any questions? Any questions for Mr. Shibuke John from Primetals Technologies? I think we have one question from a couple of questions from the attendees. So first is Mr. Rajesh Garg. If you could please introduce yourself and then ask your question. Mr. Rajesh Garg? Yeah.
Sorry, I think it was by mistake.
Okay. Then we have a question from Mr. ACR Das, followed by Dr. Mukesh Kumar. So firstly, we'll go to Mr. ACR Das.
Yeah, Mr. John, good evening.
Good evening.
I just wanted to know, what is the cost of carbon capture you are referring to? You are giving some demonstration that people are doing it, but what is the cost? Is it economical?
It's a good question. So I think today the cost of carbon capture is quite high. This is an example in the US, and the US costs are entirely different. And as per coming to India, we have not done any of those works, but certainly a similar technology exists in the chemical industry in India. So a lot of chemical companies which are producing urea uses the MHI carbon capture technology. So I think there are 4 plants in India on the chemical side. It would be the similar technology. So I think If you take a feedback from the chemical industry, you will know exactly what's the cost of carbon capture. We have still not done for the steel industry. There are a lot of talk in Europe. So we are discussing with customers in Europe, but for India, there is no discussion so far.
Okay, thank you.
So the next question is from Dr. Mukesh Kumar. Dr. Mukesh Kumar, if you could unmute and ask your question. Dr. Mukesh Kumar, can you hear me?
Yeah. Good afternoon, Amit. And it was Mr. John. It was a very, very nice presentation. Only two questions I just wanted to ask.
Yes, Doctor.
You have mentioned about LanzaTech technology.
Yes.
In LanzaTech technology, do you think that there is a need of capturing carbon or carbon monoxide and carbon dioxide gas, rich gases, can be directly used for making ethanol? This is one question. And second question is, when we are doing carbon capturing, do you think methanol also will be a possible route to decarbonize our steel industry?
Yes, the way the ArcelorMittal has done, this is the ethanol which is produced through the fermentation of LanzaTech is classified as RED labeling, which means that it is a bioethanol. So it provides its decarbonization. So, and right now it is based on CO fermentation. In the future, we can do a co-fermentation, which means the CO and CO2 can be combined with hydrogen to produce ethanol or even higher hydrocarbon. So we are right now doing a test facility to capture CO2 and CO to produce higher hydrocarbon in Australia.
But suppose if green hydrogen is available, so if we add green hydrogen into bioethanol making, then carbon efficiency will improve further.
Yes.
And it will be a better decarbonization, and I think more than 60 to 65% reduction in greenhouse gas emission in BOF route can be achieved by this route.
Yes, absolutely. You are right. The carbon efficiency is very, very high. If we can add hydrogen and green hydrogen being available in India, we believe this could be a good solution. Yes.
So then the entire scenario may change, because
Yes,
once we are in a position to reduce our GHG emission by 60 to 70% in BF and BOF route, I think we will be very close to your projection of around 1.1 or so, what you have shown in your graph.
Yes, so that's what we believe. There has to be two routes. The integrated blast furnace route will stay. So India needs steel, it will stay. They are young, so they need to find solution. And we believe other than the process optimization, which may bring in 20% reduction on CO2, the long-term solution is a carbon capture, utilization and storage. Coming to utilization, we believe utilization alone cannot also give the solution, because the other industry, the power industry would like to utilize it, the chemical industry would like to utilize it. Eventually, India has to create an infrastructure for pipeline for CO2 and storage of CO2. This has to be done eventually. To some extent, we can capture it. How much bioethanol can be produced? If all the industries start producing, it is going to be overcapacity. So we need to have a balanced, pragmatic view. There has to be some amount of production of the ethanol or a higher hydrocarbon, and some need to be still stored in, let's say, in the coal fields or the oil fields.
Thank you, John. Thanks.
Thank you very much, Dr. Mukesh Kumar. So just to introduce, Dr. Mukesh Kumar is the Director of Steel Research and Technology Mission of India, known as SRTMI. And Dr. Mukesh Kumar has been a part of many of our webinars over the last year. So Dr. Kumar, thank you for your question. And I hope that you will stay in the panel so that we can have your valuable inputs along the way as we progress through the next speakers.
Yeah, thanks a lot for the steel industry. I just want to say, if in case any of the solution would like to discuss in detail, my team would be happy to support you. We are there to provide solution for you. We as a technology supplier would like to be your partner to support you on your path towards decarbonization. So please get in touch if any of you would like to talk further. Thank you.
Thank you. So yeah, with that, I would like to move on to our next speaker. We have Mr. Anil Anand, COO, Region India and Asia Pacific, Managing Director, Paul Worth India Limited. Over to you, Mr. Anil Anand.
Yeah, good evening. And thank you very much for organizing this webinar and giving us a chance, and also choosing this very hot and burning topic, which is today. So I would just like to mention that we at Polwarth and SMS Group are working a lot into the area of developing technologies for reducing the CO2 reduction and also the roadmap for the green steel. Now I would request my colleague Cristiano from our Center of Competence from Europe to present our point of view on the subject. So over to Cristiano.
Thank you, Anil. Mr. Ankit, if you can share the slide I sent you.
Yes.
So that I can start the my intervention.
Mhm. Just give me a moment. I think it's a big presentation, so it's opening.
Just to mention now, Polwarth is fully integrated in SMS Group. So we are now part of the Competence Center Iron, which involve technologies related to blast furnace and direct reduction. I'm part also of the so-called Green Steel Task Force. SMS Group has set up a team of experts focusing only on what is needed to come to the green steel production. So I'm taking inspiration of the activities that we have done in this task force to propose today a possible solutions that it will help the iron and steel industry in India with its specific features to come closer to the objective at a viable cost. So you see here, okay, there is some problem. I see my computer. I don't know why, but I think you are seeing the first slide in which I entitled the subject of my speech as a smart integration of DRI production in existing integrated steelworks. And you see in the pictures above two units that Polwarth has been active in bringing to the reality. One on the left is the DRI production plant in Algeria, Algerian Qatari Steel, and on the right you see the Vizag blast furnaces. The two installations both are designed for 2.5 million tons per year, and this can make the audience understand that today the capacity issues is already between the two technologies is already closing the gap, since also a single DRI unit can produce 2.5 million tons per year. Next slide, please. As a matter of fact, the SMS Group is in a very good position to speak about the smart integration of technologies, because we can take inspiration and knowledge from a constellation of technology suppliers that you can see here. The SMS Group, the Polwarth, the Emetics, which is a company located in South Africa, which is one of the leaders in the technology for the submerged arc furnace for producing hot metal, through also through DRI, and the Midrex technology, which is the leading one today in terms of direct reduction based on natural gas. Next slide, please. When I spoke about the capacity of the DRI unit in a single installation, I'm talking about facts, not only about the design figures. You can see that in 2020, the plant located in Algeria, as designed by Midrex and Polwarth, has been able to produce 2.2 million tons per year of DRI. This is the world production record from a single direct reduction module, and this proves the reliability of this technology. Starting from this point, we thought how to make an hybrid configuration of steel production, trying to get the advantages of the solution of DRI and electrical smelting together with its lower carbon footprint without penalizing the cost of production in compared to the blast furnace and BOF route, and also minimizing the capex impact. So this next slide, please, is showing on the left what is the standard way one could think for integrating the DRI plant on an existing setup, which you see on the bottom, which consists of blast furnace and BOF route. Obviously, the first thought could be to produce directly steel using an electrical furnace or a compro, which is a technology from SMS Group for increasing the flexibility and efficiency of the EAF, but charging the electrical furnace with hot DRI coming from a DRI plant, which can be fed also by syngas, as it is done today in JSPL, for instance, from syngas from coal or natural gas or other gases containing CO and hydrogen. This EAF would produce liquid steel, and this liquid steel would be charged to the existing caster. This could be also thought as a possibility to have a two-step approach in which you start with scrap only to the electrical furnace, and then you later install the DRI, because this is a possible deferred combination of technology given by the possibility also to charge the EAF with a certain amount of hot metal. One disadvantage of this route is that the slag grade, the slag type you get from the EAF is not so attractive from a marketing perspective. There is no such a big value from this slag, unlike the blast furnace slag. And the other problem was already mentioned today, is the high cost and supply chain constrained characteristic of the DRI grade pellets that are needed in this case. So the idea would be to go on the right side of the slide, in which you see that the DRI plant is feeding a submerged arc furnace, SIF, which is also producing hot metal, and this hot metal is then fed to the existing BOF as today hot metal from blast furnaces. The advantage of this solution is that the slag coming out of this plant can be processed to get the same type of slag that you are getting from blast furnace, that you are selling to manufacturers, cement manufacturers, or as a substitute for clinker. And the other advantage is that this facility is a very powerful device to recycle and valorize wastes. We heard before Dr. Saraswat asking for a solution to handle, to profitably handle these wastes of all type, and this device can really become a powerful tool for achieving this target. This right-hand solution has also the advantage from a capex perspective that the downstream metallurgy can be fully utilized. The quality of the steel is the same, and also the fact that operation of the BOF will not change compared to today, is differing from the left-hand solution, in which the EAF can become something too difficult to operate, because it can have 3 inputs stream: the DRI, the scrap, and the hot metal. Next slide, please. Why the right-hand solution is so important to be explored in today's market? We have analyzed here the OPEX breakdown structure of a DRI plant, a typical DRI plant, which is operated nowadays in Europe, but this is not significantly changing for other reasons. And you can replace natural gas in this slide with coal and gas, doesn't change so much. The important message of this slide is the red written sentence. Almost 70%, the 70% of the operating cost of the DRI is DRI production is linked to the iron bearings, which are normally pellets. And this becomes the real issue of the DRI production for electrical furnace, because as previously mentioned by Mr. Ravi Singh, the cost of DRI pellet is DRI grade pellet is very high. Next slide, please. Why this cost is so high? Because not because of the DRI itself, DRI technology itself, but because of the use of the DRI is aimed to in the subsequent step of electrical furnace. Electrical furnace has, in fact, a certain loss of iron in the slag, and this loss is higher with the higher volume of slag. So this means that to produce a ton of steel, you lose a lot of yield and also electrical energy to melt the additional material per each ton of additional gang. You see here the typical ratio. So moreover, there are slag formers needed to take care of this gang in terms of final chemistry, and all in all, the importance of having low gang in the starting iron ore is really a key point for the profitability of this route. On the contrary, the next slide, please. On the contrary, we see that this tendency of having the requirement of the DRI grade pellet in the market is absorbed by an expected increase of cost. You know that the DRI pellets today are DRI grade pellets today are a commodity, and so the price, the evolution of price can be studied and anticipated by business intelligence company. We have asked to one leading company in this segment to have a forecast of what is the DRI premium, DRI grade pellet premium in the future, and you see that from the graph on the left, the differential cost between DRI grade and BF grade pellet is going in the range of 30 to 40 euro per ton of pellet. So you see the cost of BF grade in green and the cost of DRI grade in orange. So this means that there is a significant, considering also this 70% on the total OPEX impact we have seen before, let's say this factor is really important in evaluating the differential operating cost of something which uses DRI grade or BF grade. Next slide, please.
Mr. Castagnola, just sorry to interrupt you, but I just read some people in the chat are having a problem viewing the presentation. So I will just try to fix it. I mean, they're saying that some parts are not visible. There are blocks on the sides apparently. So yeah, so I would like to ask the panelists: is it better now? Is it visible?
Not really, totally.
No, it's the same as it was.
I see.
Is it a very big file?
No. The concept is relative. Big depends on the. Yeah, maybe now it's better.
Okay, let's keep it like this then. Yeah.
Before the slide before, please.
Yeah.
Yes.
This one, yeah.
This one, yes. So considering this differential cost, we have thought this solution, which can start from blast furnace grade pellet to produce hot metal without any bad consequence that we have shown in the DRI EAF grade. So we are coupling a Midrex module that you see on the top with one or two modules of SIF, which is a submerged arc furnace, which is using the electrical power to smelt the hot DRI. And this SIF technology is operated in the so-called brush shielded arc mode. You can see schematized in the central sketch, in which the electrodes are slightly lifted from the bath, and the DRI is placed on the side of it. So, and it is melted continuously and smoothly in to become hot metal, adding fluxes and a small amount of carbon. This technology is provided by a company called Metix, which is part of SMS Group, which has a lot of references for SIF and SIF smelting, also hot metal, iron ore, and this means that the technology is established, proven, and can produce per single module up to 1.5 million tons. So we have this combination that from the overall perspective can replace a blast furnace, next slide please, to produce 2.5 million tons. You see here how this solution would like. This is, I would call, an electrical blast furnace, because at the end you have coming out, you see on the center at the bottom, the hot metal in the torpedo railway car, and then you have a tower in which on the top you will charge iron ore. This can be coupled, for instance, with the coal-based syngas, and the carbon footprint of this is more or less 40 or 50% of a traditional blast furnace, even with coal syngas. So I would say this DRI plant SIF unit can be smoothly introduced in any existing facility, thanks to the fact that it has not to be closer to the steelmaking, because as it is to be treated as a normal blast furnace from the point of view of product logistics. It's the only thing to do is to connect it to the existing railway track for torpedo cars. Next slide. Another key advantage of this SIF technology is the possibility to digest and transform in hot metal also the complete set of wastes that are already in steelmaking production. So in our plant of steelmaking today, we have high moisture waste like BOF or blast furnace sludge. We have coarse waste, mill scale, mill sludge. We have also fine, low moisture waste like BOF, BF dust, the dusting dust, sinter dust. And you see here that these three streams can be treated with a very simple technologies to become fine dry dust, which can be directly injected up to the 5% of the total input feed to the SIF, or can be pelletized, cold pelletized, or briquetted, cold briquetted to be added to the SIF in any proportion. So this will result at the end in a sellable slag, because it will be like a blast furnace slag, and in automated production, plus some dust which will be probably rich on zinc, and so can be also sold in the market. Next slide, please. Considering all this, we have made an OPEX comparison mapping of the two solutions we have spoken about. I'm talking about gas-based DRI or syngas-based DRI plus EAF versus that you see in the yellow part, and the blue part, which is SIF BOF, SIF with the DRI. And you see that this is the minimum OPEX mapping. So means that according to the two variables shown, the electricity price on the horizontal axis, and on the vertical part is the DRI pellet premium, you see that today we have a very large predominance of OPEX competitiveness versus the DRP SIF solution. You see on the right the cost that we have considered. The NG can be replaced by coal syngas like in India, but at the end, my final message is the same. Next slide, please. So this is the end of my presentation. I'm just here to answer any questions that the audience may have. Thanks a lot for the organization of this opportunity.
Thank you, Cristiano. Any questions for Mr. Cristiano Castagnolia? Any questions in Q&A section? Is Dr. Mukesh Kumar? Dr. Mukesh Kumar is there? Do you see Dr. Mukesh Kumar, Ankit?
I think he was here.
अभी सब चले गए भैया, बहुत 7 बज गया अब नहीं कोई है। आपका जो टाइम मैनेजमेंट इज टोटली हेवायर यार। अंकित नहीं, अभी अगली बार हम छोड़ देंगे।
भटनागर साहब हम बैठे
नहीं नहीं, ये अंकित, अरे अनिल आनंद, आपका जो प्रेजेंटेशन था बिल्कुल ऊपर से निकल रहा था यार, ऐसे थोड़ी होता है यार। हम भी स्टील इंडस्ट्री में काम किए 30 साल। आप 1.5 घंटे का प्रेजेंटेशन, उसकी बात ही समझ नहीं आ रही थी। चलो ठीक है, आई एम वेरी अपसेट।
ठीक है,
थोड़ा सा प्रैक्टिस होनी चाहिए यार।
इतना गुस्सा मत
होइए, अच्छा नहीं लगता है मुझे, और कोई बात नहीं चाहिए।
ऐसी एक चीज आप समझा कीजिए, इफ आई कट शॉर्ट एवरीवन्स प्रेजेंटेशन, तब तो कोई किसी को सुन नहीं पाएगा। ये भी समझा कीजिए। तो विदाउट एनी ऑफेंस,
समझ गए।
ठीक है, नेक्स्ट इट इज योर टर्न। दीपक जी, इट्स योर टर्न। यू कैन टेक एज मच टाइम एज यू वांट। आप कॉम्पेंसेट कर लीजिए, आप जितना देर बोलना चाहते हैं बोल लीजिए।
नहीं, हम नहीं बोलेंगे, हम हम यही बोलना चाहते हैं. देखिए, anyway, good evening. Hello, is my voice face coming?
Yes, we can hear you.
Acha, good evening. Actually, I am almost at the end, but I realize it's almost 7:30 or something, 7. But I just want to make your life little simpler by not giving you a very heavy presentation with hundreds of graphs and hundreds of data. Most of this data is known to all the people in the steel industry. But I don't want to bore you. I just want to tell you about a love story. Are you listening, all of you? हमें तो अपना चेहरा, I'm not able to see if my face is.
Yes, we are listening, Bhatnagar sir.
तो ऐसा है, सक्सेना साहब अभी आए सामने, तो एक छोटी सी गुजारिश है आपसे, आप सब ब्लास्ट फर्नेस वालों से, कि पेलेट इंडस्ट्री के बारे में थोड़ा हम बताएंगे जो हम बताना चाहते हैं, बट एक छोटी सी लव स्टोरी सुनाना चाहते हैं, क्योंकि बहुत आपने ग्राफ झेल लिए, बहुत डेटा झेल लिया. हम आज से 50 साल पहले भिलाई स्टील प्लांट, क्योंकि हम क्यों बोल रहे हैं, जब भिलाई स्टील प्लांट के एग्जीक्यूटिव डायरेक्टर को मैंने सुना, मिस्टर A.K. भट्टा, वो मेरा दिल खुश हो गया. मैंने 50 इयर्स पहले भिलाई स्टील प्लांट से मेरा लव अफेयर शुरू हुआ, ब्लास्ट फर्नेस से, और तब से मैं अब तक स्टील इंडस्ट्री में जुड़ा हुआ हूँ. बहुत सारे ग्राफ मुझे नहीं आते, क्योंकि हम शॉप फ्लोर में काम करते थे, हम बहुत ज्यादा फंडे नहीं है मेरे. बट एक चीज जो डॉक्टर सारस्वत ने बोली, और मैं जितने ब्लास्ट फर्नेस वाले आज इस मीटिंग में हैं, जैसे सक्सेना साहब दिख रहे हैं, हमें मिस्टर संतोष दिखे, मिस्टर प्रभात भोराई दिख रहे, सिद्धार्थ मिश्रा जी की बात सुनी. एक वी शुड ट्राई. होता क्या है, सब अपने अपने कंपार्टमेंट में बैठे हुए. जो पेलेट इंडस्ट्री, उन्होंने भी यही कहा, आप अपने बारे में सोचते हो, पेलेट इंडस्ट्री की बॉटम लाइन के बारे में सोचते रहते हैं. मगर हम एज अ एसोसिएशन सेक्रेटरी जनरल, आई फील we should have a common platform in which pellet people should talk to blast furnace. This is my humble request. Now, everybody knows that the use of pellets versus sinter, everybody knows. But there is no, the tragedy, Saxena Sahab, is there is no data from India to prove it. ये जितना डेटा हम लोग बोलते हैं ना, जो अभी मैं वो बताने जा रहा हूँ, ये सब पेपर्स में पब्लिश होता है. Use of pellet in blast furnace decreases emission rate of carbon dioxide by 85%, SOx by 90%, NOx by 20%. कल को कोई पूछे कहाँ का डेटा है भैया, ये जानते हैं कहाँ का डेटा है? ये वर्ल्ड स्टील डायनेमिक्स का डेटा है, सक्सेना साहब का डेटा नहीं है ये, या टाटा स्टील का डेटा नहीं है. ये अफसोस है. जब आप पेरिस में प्रेजेंटेशन करेंगे, हमारे प्रधानमंत्री के जो प्रतिनिधि हैं, वो पूछेगा भैया ये सब डेटा तुम कुकअप किए हो कि एक्चुअल डेटा है इंडिया का. तो माय हम्बल रिक्वेस्ट इज वी शुड मीट टुगेदर, टेक्निकल सेमिनार्स एंड नॉट दिस थिंग. सो नंबर 1 वाज द यूज ऑफ पेलेट्स इज ऑल अबाउट सस्टेनेबिलिटी. it's a way to make greener steel. Number 2 is it gives you much better bed permeability, जो ब्लास्ट फर्नेस लोग जानते हैं. इसको कोक रेट 20% कम होता है. अगेन ये डेटा इंडिया का नहीं. हमने टाटा स्टील वालों से बहुत गुजारिश करी कि टाटा स्टील इज द टेक्नोलॉजी के मामले में बहुत आगे है. हमने कई सेमिनार्स अटेंड किए हुए. हमने उनके जो पेलेट प्लांट के हेड हैं, उनसे यही रिक्वेस्ट की, कुछ डेटा जनरेट करिए. सिंटर से आपने कैंपेन चलाया, पेलेट से चलाया, 50-50 चलाया, क्या रिजल्ट? कंजर्वेशन ऑफ मिनरल. Pellet use say you conserve mineral. It is domestic value addition of around 80 million tons of iron ore fines, which is about 5% growth year by year. Pellet industry consumes about 50% of the raw material value. And last but not the least, pellets provide almost green value added material to the steel industry for both blast furnace and DRI. Higher tumbler index से DRI, everybody knows higher tumbler index, higher productivity. So this is, in short, the benefits of blast furnace. Somehow we should exchange notes. Why? When Mr. P.K. Singh was chairman SAIL, he's from Roorkee IIT, मेरे से 5-6 साल जूनियर थे, मैं उनसे मिलने गया, मैंने सर आप ब्लास्ट फर्नेस के आदमी हो, आप सेल में क्यों नहीं यूज करते हो? कहते नहीं, अब दिल्ली में प्लांट आ रहा है, ये 3 साल पुरानी बात, अभी आ रहा है, चलो ठीक है। दूसरा एक बहुत बड़ा इंपॉर्टेंट पहलू है, डॉक्टर मुकेश कुमार जानते हैं, I have been raising in every seminar that something like 100 million tons of iron ore fines is lying at pit head. कुछ तरकीब निकालनी चाहिए कि उसको यूज करो पेलेट में, उस पे भी 20% रॉयल्टी ले लोगे, कोई नहीं यूज करेगा। ये तो बड़ी सिंपल सी बात है यार, कोई भी बनिया होगा वो जानता है, मुनाफों में घाटा कोई नहीं करेगा, है ना सब। एक लास्ट पॉइंट आपको बताऊं, बहुत अच्छी चीज डॉक्टर मुकेश कुमार ने मुझसे शेयर की और हमने भी पढ़ा इसकी वेबसाइट। एक स्टैंडिंग कमेटी बनी है ऑन कोल एंड स्टील, उसमें पार्लियामेंट्री स्टैंडिंग कमेटी है, मिनिस्ट्री ऑफ स्टील ने बनाई थी। उसने इतना गजब का स्टेटमेंट दिया है जो मैं जस्ट आपको बताना चाह रहा हूं, ये बिल्कुल ताजी खबर है, स्ट्रेट फ्रॉम द ओवन। उनकी जो 17th लोकसभा को उन्होंने ये बोला कि बेनिफिशिएशन के लिए द मिनिस्ट्री ऑफ माइंस हैज बीन रिक्वेस्टेड टू फ्रेम अ पॉलिसी फॉर प्रोवाइडिंग इंसेंटिव्स टू द बेनिफिशिएशन एंड एग्लोमरेशन इंडस्ट्रीज। उन्होंने कुछ सजेशन दिए, एक्साइज ड्यूटी कम कर दो, इंपोर्ट ऑफ मशीनरी पे कस्टम्स कम कर दो, टैक्स हॉलिडेज, मिनरल। बट जो सबसे बड़ी चीज इन्होंने नहीं लिखी है, जो आपको हमको मिलके करनी है, कि रॉयल्टी कम करवाइए। तो रॉयल्टी जिस दिन 20% से 0 होनी चाहिए, ये एक है। एंड फाइनली द लास्ट सेंटेंस ऑफ द कमिटी टू द प्राइम मिनिस्टर इज, द कमिटी देयरफॉर रिकमेंड्स that the Ministry of Steel should pursue the matter with the Ministry of Mines for early framing of a policy for providing incentives to the beneficiation and agglomeration industries. So let us sit together, all of you, Saxena साहब आज सुन रहे हैं, बाकी जितने blast furnace वाले हैं, let us find and थोड़ा सा साहब सक्सेना साहब ये गुजारिश करूंगा आप लोग से blast furnace कि you are the big brothers. All said and done, हम खुद इंटीग्रेटेड स्टील प्लांट में पैदा हुए हैं, भिलाई स्टील प्लांट में 25 साल निकाले। तो अब हम समझ रहे हैं कि इंटीग्रेटेड स्टील प्लांट्स हैव टू टेक द लीड और पेलेट प्लांट को बुलाएं अपने यहाँ बुलाएं या ऐसे ही जूम पे बुलाएं एंड से कि व्हाई नॉट इंप्रूव द क्वालिटी। अभी क्वालिटी इज वर्ल्ड क्लास, यू नो दैट इंडियाज पेलेट्स आर गोइंग ऑल ओवर द वर्ल्ड, पर्टिकुलरली चाइना जैसा कंट्री हमारा करीब 13 मिलियन टन खरीदता है। तो वी आर प्रोड्यूसिंग गुड क्वालिटी pellets. The only thing is we need to work together and do progress the pellet industry further, not because I am the Secretary General, but it is technologically much better. Thank you Nirmalya ji, I am sorry मैंने थोड़ा आपको बोला because काफी बोर हो गए थे असल में, और कोई बात नहीं, इसलिए हम माफी चाहते हैं।
I'll be in touch with you. Just Saxena from the state, sir. Take a Saxena.
हाँ.
Sir, I'll be in touch with you. And just for your information, that RINL started using slime.
Correct.
Back in 19 to 20, we used 9%, and then last year we have used 24%. And this year again we are in the process of taking it to 30%.
अच्छा, नहीं तो स्लाइम्स को आप एग्लोमरेट करते होंगे ना?
हाँ, स्लाइम्स को लाके हम सेंट्रल प्लांट में यूज करते हैं।
अच्छा।
When we started using slime, it was 900 rupees, 950 rupees per ton.
Okay.
Of course, now the prices have gone up. But I mean, since you mentioned that lot of material is lying on mine head, so I thought I should mention it that RINL started using it just 1.5 years ago.
Okay. So thank you everybody. Thank you very much.
Thank you Deepak ji. Thank you so much. Thank you so much. देखिए, you are almost like a father figure to me. You are in your 70s and I am touching 50. So बस इतना तो मानते हैं कि आप, your wish is my command. आपने जो कहा सही कहा, absolutely I agree with you. लेकिन आप ये भी समझा करिए कि people, if they have to rush through their presentation, it is impolite on my part to tell them please rush through.
नहीं, let them not rush. एक छोटी सी गुजारिश है, देखिए जब प्रेजेंटेशन बनाता है आदमी, तो अगर 50-60 स्लाइड होंगी ना, तो रश तो अपने आप 1.5 घंटा लगेगा उसको। तो मतलब कि 4-10 स्लाइड बनाए, ये थोड़ा आप आदेश दे सकते हैं लोगों को। ये अपनी
ये देख लीजिए मेरा प्रोग्राम में क्या लिखा है, एकदम क्लियरली लिखा हुआ है, बाकायदा 10 मिनट हर एक प्रेजेंटर के।
पर कोई सुनता नहीं है आपकी बात।
एग्जैक्टली, इसीलिए मेरे बेटे का एक एडवांटेज है, he doesn't know everyone in the industry, so he can afford to be a little stronger than
नहीं, ठीक है, कोई बात नहीं।
So because all are my very good, these are 20-30-year-old associations, so I can't afford to be impolite to anyone.
impolite नहीं, उनको ठीक है, हम समझ रहे हैं आपकी दिक्कत भी है, बस अल्टीमेटली उन्होंने स्पॉन्सर भी किया है, इसलिए कोई बात नहीं।
लेकिन ये भी तो है, अपना पापी पेट का भी सवाल है। So with that, let's move on to our next presentation.
Next.
Yeah, so let's move on to the next presentation, which is Mr. Enrico Plazogna. He is the Executive Vice President Sales for Danelli Automation.
Yes.
And you are in booth 3 right now, right?
Yes, I'm in booth 3, yes.
Okay.
Let's see if I can manage to share the screen.
Yeah, please go ahead.
Yes, thank you very much. Yeah, should be this one. Can you see my presentation?
No, we can see your Teams window open.
Oh, yeah. So this is the wrong window. I should go on the other. Let me see. I move the presentation on this side. Then. Let's see. Yeah, now it should see. It should work.
Yes, now we can see it.
Yeah.
Perfect. Okay, we decided, Daniele, to go straight to a very short and informative presentation. We thank the previous panelists. They went very, let's say, they gave a overview of the different possible solutions which are known to overcome the issues of CO2 emissions, which is becoming of primary importance in Europe, but it will become important for everybody, as it was said by all our colleagues. Now, what are the changes? We will focus on the EAF route. Although you know that in Danieli we have also excellent solution with Danieli Coros, well known on the Indian market for blast furnaces. We focus in this case, a specific case, on the electrical furnaces. So, which are the issues for the electrical furnace route? Well, first of all, the disturbances of the network, which is, of course, sometimes also installing electrical furnaces in areas where blast furnace was used before is not so easy because of the other grid. The issue of cost savings, being competitive is a must. Having an environmentally friendly solution with low CO2, low pollution, and low noise also from certain that can be important, and the quality of steel. When we use electrical furnace, we know that the quality can become it's something to be taken care of, and this can be very well solved using DRI, HBI, and as Mr. Martinez, that after my presentation will describe in detail. Speaking of electrical furnace, we have a very interesting and I would say revolutionary solution for feeding the furnace using a power electronics to control the arc current and voltage, meaning that practically we can this is the traditional solution, let's say, when you use a SVC system to let's say compensate the disturbance of the furnace. We have a solution, innovative solution based on this Q1, as we call it, which is basically power electronics controlling each single electrode in current and voltage. This is is giving exceptional results, which we are very proud of. This is a patented solution. And the biggest advantages, this is an existing plant installation where we did most of our tests, and now we have almost 10 references worldwide. Why I'm saying that this technology is bringing a very important innovation? Well, first of all, we need to take care of to minimize the to optimize quality and to minimize consumption and CO2 emissions. So we have to take care of the scrap, manage the scrap at the entrance of the plant. We are considering as our primary solution for in the case of scrap charging, the endless charging system. So no roof opening, shortest power of time, lowest energy consumption, and an environmentally friendly solution. We have advanced automation, which is also helping a lot in increasing sustainability by reducing delays in the production, and by adopting also artificial intelligence and solutions to improve the melting process. While when we charge scrap, we have different possible solutions. The preferred solution and the most effective and efficient is the one, of course, with a direct hot charging of scrap, similar to the plants, because we have more than one unit of the similar size and type in Emirates Steel, in Egypt, in ETS, and Mr. Martinez will tell you something about this. So these are ways to produce quality steels through an electrical furnace in a very efficient and with very low emissions of carbon. I would say typically much less than half of the CO2 emissions of a blast furnace. Again, in the next presentation, we will see some figures. Importance of the management of scrap for the quality, as we said before. Importance of handling, not only handling the scrap, but even selecting the quality of scrap you're charging in the furnace. All this can be done fully automatically. Use of renewable energies to feed the furnace. So what we are achieving with this Q1 is the possibility to, let's say, use the power of the sun to melt the steel. Looks like a dream, but it's something which is already feasible, is already available, because we can connect directly the DC link of the Q1 to the, for example, to a photovoltaic field or to a wind generation. We believe that this is really the future. This is really what will more and more happen, not only in Europe, for sure in Europe, because it will be mandatory, but then these technologies will spread all over the world, also because Europe will impose taxation to CO2 produced steel. And at the moment, Danieli is the only company having such technology and having this patented technology. So we are the only one able to feed the furnace with the renewable sources. The importance, one important advantage is also that we don't need SVC, we don't need compensation systems, because this technology is intrinsically very, let's say, very clean, very sustainable towards the grid. So we don't generate harmonic distortion, we don't generate voltage imbalance. We have a power factor which is typically 0.97 all the time. And also we have developed tools to manage the, say, hybrid solution, as I mentioned before. So we have developed tools, software tools, to route, to control the mixed energy sources available, to have an energy aware production planning and execution, because the cost of energy also depend on the time of the day, and so we can, for example, produce the most costly production during the lowest cost hours. So coming back to the first slide, we have with this Q1 we can solve many of the issues for the electrical furnace route. We can have a minimum impact on the grid, so we can reduce the disturbances on the electrical network. We don't need an SVC. We have cost savings in terms of OPEX savings, because we have, sorry, there is an automatic. We can have higher productivity, typically in the range of 10-15%. This is what we saw. A lower OPEX because we can have a lower consumption of electrodes and other advantages of this kind. We are environmentally friendly because we can use renewable sources to feed the furnace, and also it's a small detail, also less noise. And still, for the quality of steel, we can work on the scrap classification. We have a continuous charging system with a zero bucket solution, and for this I will leave the speech to Mr. Martinez. The application of DRI, cold and hot charging of DRI into the electrical furnace. And I managed to stay just 1 minute over the 8 minutes, which I was allowed. Thank you.
Thank you so much, Mr. Plazoina, for finishing well before time. I'm sure Mr. Bhatnagar will be happy.
Yes, exactly.
He will be happy that we didn't eat into the time. And my special thanks to you. And Q1, I see as an excellent product. I see this as a game changer.
Yes, we believe also.
I believe it's a game changer for the entire industry, and I'm sure in the days to come, this will turn out to be a hot cake.
Also for the Indian market, which is now more focused on blast furnaces, but for sure in the long term, it will move also on electrical furnaces.
Yes, this is what, whenever I get to meet Mr. Benedetti, I always tell him one thing during the press conferences, that you must come out with low-cost technologies. Electric arc furnace is there. At the same time, if you somehow visualize solutions with induction furnaces, for which in India there are numbers of induction furnace units.
Yeah, I know.
So these solutions, low-cost solutions, I think Danelli has the capability of doing it. And by virtue of having your workshop in India, in Danelli Far East, also in Butrio, you have the possibility of delivering low-cost products, which are basic, but can do wonders. So with that, I thank you once again. And my next speaker is Mr. Martinez, who has addressed us before also. And whenever I get a chance to visit Butrio, if you have the DIM next year, I will be there for sure. I understand as of now, nothing is finalized, but if you have the DIM next year in Butrio, I'm sure I'm going to enjoy the best of wines of Friuli with you.
And we will be pleased to meet you.
Yeah. So, thank you so much. Grazie. And now I move on to Mr. Martinez for the DRI part. Mr. Martinez, the floor is yours.
Yes, I hope you can see my screen and also hear my voice, because before there was a problem with my microphone.
Yeah, now it's fine.
Okay. Okay, I want to give a brief overview of what we can think to give as a contribution to the decarbonization of the steel industry. I will not go into the detail of the technologies, because I think so many qualified speakers before me have done it. And so I just want to throw some ideas on the field to see how we can together work on this field. So it is clear that, as we all know, the blast furnace and BOF route is the most developed and, let us say, common way to produce high quality steel. Single modules can have very high productivities. Also, with very high quality of steel can be produced in this way. And nowadays, almost the entirety of the production of automotive exposed parts, for example, is done with this route. Nevertheless, we all agree that there is a high environmental impact, and not only in terms of CO2 emissions, of greenhouse gases emission, but also due to the presence of coke ovens and other polluting, the sinter plants, etc. The other pollutants are released to the environment from this route. On the other side, we have the Scrap-EAF route. Well, scrap, we have learned during these presentations that is available in big quantities, but scrap has also some drawbacks, not only availability, also quality of scrap. So not all the steel grades are accessible with the scrap-based metallurgy. Although we all understand that this route can have a very, very low environmental impact, because, as Mr. Platonia said, we can use green electricity to feed also the electric arc furnace. And intrinsically, the recycling of scrap means that we are not disseminating into the environment products of our industry, because everything still is recyclable 99%, so we know. Then we come to the DRI reduction plus EAF or Danieli digital melter, for example. One question that was asked before in this seminar was, yes, but the DRI reduction can take the lead only if the productivity of a single modules can go to very high capacities. For example, we have already installed modules of 2.5 million tons per year that are overlapping the capacity of the blast furnaces. So this is one thing. And the second thing is that any quality of steel, also high quality of steel, can be achieved with this route. We have examples, for example, in Monterrey, where an Energiron plant is feeding an electrical furnace 100% hot DRI with very high carbon content, 4% carbon content. So it is a kind of solid hot metal. Allow me this game with the words. And they are producing plates for automotive. Not only that, we have also plants, for example, in Egypt, where low quality pellets are used. For example, blast furnace pellets have been used in some plants up to 30–40%. And this depends, of course, also on the price differential between DR grade and blast furnace grade. Reduction of emissions must go down, must be implemented, especially in the Western world. It is a must, because our governments and the European Union is imposing this. Also, a lot of money have been injected in the market to do this transition. And China is also following, although with some delay, but in the 5-year plans, they have also put some money for studies and pilot plans in this direction. In China, we are now installing two plants based on DRI reduction. And since we know that in China natural gas is missing, they have a system to recycle coke oven gases or to produce synthesis gases. But this is a starting point. The final point will be to use hydrogen generated by electricity coming from nuclear power plants or from renewable energies. We will see. I'm very confident that China will do steps ahead. And India. India is already ahead in the DRI technology. We know that many important players like Tata, Jindal, and others, they have and they operate with very good success the dye reduction plants. And the road is already traced and must be pursued, in our opinion. Also, as we have said, hydrogen will be available at very good prices in the next future. Very good prices means that if we go in the range of $2-3 per kilograms of hydrogen, then will be in comparison with natural gas normal prices, and considering also the carbon taxation, this will make hydrogen accessible and commercially successful also. Energy-iron DRI plants can utilize hydrogen up to 100%. Without any modification of the basic circuit. This is something that differentiates a little bit our technology from the competitors. Since we have a circuit that is already taking the reducing gases from external reformers or from syngases production, we have no necessity of changing anything if we put hydrogen as a part of the makeup gases. Maybe we can start with low amounts, 10, 15, 20%, and then we can increase slowly. And the only thing that will change is that the more hydrogen you put in the input gas, the less CO2 you will produce. So the CO2 removal will get smaller and smaller, but it can be bypassed in principle. Another thing that is characterizing the process is that we have intrinsically in our process a capture of the CO2. All the CO2 generated by the reduction reaction is captured and made available for successive utilization or sale. I want to say that our customers typically do something with the CO2. Emirates Steel is using the CO2 for enhanced oil production, pumping in the oil wells. Nucor that you see in this picture in the United States, they sell to the local pipeline the CO2, and then it is used by chemical industry, maybe also for production of fertilizers like urea and others. And in Monterrey, they sell it for food and beverages. They made sparkling beverages with the CO2, etc., etc. So far from being a waste, it becomes a resource. So approximately 250 kilograms of CO2 per ton of DRI can be sold. And this makes the environmental impact of the route, Energy-iron plus melter, much more convenient than what we said before, 1.4 kilograms per ton of liquid steel. It will go to around 1 if we consider all the inputs. Just not to consume too much time, I want to spend a word about the utilization of the DRI in the traditional BOF route. We have heard that there are many solutions. One solution that we are going to hopefully implement in the future, but it will be the basis of our Chinese future jobs, will be to melt the DRI. Even low quality DRI coming from low quality pellets, means with pellets that have low iron content, in melters that are not decarburizing. So in reducing atmosphere without oxygen. And this allows us to produce a liquid that can be mixed with the BOF feed, in order to utilize all the downstream from the BOF downstream and don't modify the existing production routes. This can be a very important transition phase while waiting for the complete say substitution of the traditional road to the BF as the DRI-EAF. This we call blast furnace 2.0, because we will have the same product as of a blast furnace, but with a completely different concept. I will stop here, not to consume too much time. Of course, we are available to deepen the discussion if someone is interested. Thank you so much.
Thank you, Mr. Martinez. Thank you for once again finishing well on time. And I would say this is again a very interesting presentation, which highlights the possibilities of mix and match of technologies together. So with that, I would just like to ask you, are there any questions for either Mr. Martinez or Mr. Plauzona? Yeah, Sanjeev, please go ahead.
Yeah, Mr. Martinez, it is excellent presentation. Just got a question regarding DRI in the blast furnace. So when we talk about DRI going to the electric arc furnace, we all get concerned, worried about high-grade pellets availability. How about DRI going to the blast furnace? Do you still need high-grade pellets? That's the question number one. Question number two, do you have any pilot plant as on today operating where you're using low-grade iron ore to produce DRI, which would go into the blast furnace? Thank you.
I'm answering to the first question. The top part of the blast furnace is rather oxidizing. So we think that utilizing DRI is not a really good solution. Also because the DRI typical compression strength is not so high. So you probably end up losing the benefit that you are looking for. Instead, we can think of using HBI in the top part of the blast furnace, because HBI is a little bit more compact, so it will resist the oxidation to the top part of the blast furnace until it reaches the let us say, zone where, I don't want to say the mushy zone, but the central zone of the blast furnace is where it can be melted. Of course, I think we cannot increase over a certain amount the HBI content, because you need in any case some coke for giving to the blast furnace burden a certain mechanical resistance. And if you have too much metallized material, then the overall energy balance of the blast furnace will be compromised. So I think that 20% can be a good compromise to minimize the carbon, coal and coke utilization. About the second question, we don't have a pilot plant utilizing very low grade pellets in this moment, but in its plant in Egypt, we were using up to 30% blast furnace grade pellets from Russia. And the results were nice, but we discovered that it is, convenient from the economical point of view to use blast furnace until the differential price between the DR grade and blast furnace grade is more than $30 per ton. So if it is less than $30 per ton in the current market situation, it seems that it is more convenient to buy higher grade pellets. There is no real limitation in the DRI plant. Of course, there is limitation in the electrical furnace in the sense that you have more slag, and so you consume more electricity, more refractories, etc., etc. So this is, but we are studying a solution to modify the electrical furnace to operate more as a kind of submerged arc furnace. It will be a closed and completely enclosed furnace with a bigger bath diameter, etc. We don't believe that submerged arc furnace is a real solution because they are very big piece of equipment. For example, just to melt 1 million ton per year, you will have a 20-meter diameter furnace, not tilting, with long time to start and stop. not so very flexible. So you lose the advantages of the electric arc furnace.
Thank you.
Thank you, Mr. Martinez.
The pleasure.
So with that, thank you, Sanjeev. So I will come and join back before your presentation, Sanjeev. In the meantime, there are 3 presentations from refractory manufacturers. First is Aditya Soni, Head Sales and Marketing, Central and South India, Calderys, India, followed by Dr. Narendra Kumar Mishra, R&D Head, India, West Asia and Africa, RHI Magnesita. And after that is Dr. Andreas Mutke, Vice President, Global Technical Services, Dalmia OCL, Germany. So to carry you through the next 3 presentations, the moderator would be my son, Ankit Mukherjee. Ankit, you carry us through the next 3 presentations and I'll be back after that.
Yeah, so our next presenter is Mr. Aditya Soni, Head Sales and Marketing, Central and South, Calderys, India, Refractories Limited. Over to you, Mr. Soni.
Thank you, Ankit. Am I audible?
Yes, we can hear you.
Yeah, I'll just share my screen. Is it visible now?
Yes. It is not full screen. It is visible, but yeah, I think it is.
Now it's fine?
Yeah, perfect.
Okay, so thank you. Actually, it's been long evening time. So I'm not already much has been spoken about the various routes of the steel making. So I'm not going to take much time on that. I'll straight away move to the topic of Indian steel making challenges right now and how refractory industry can contribute to that challenges. So if you'll see in India, steel making is carried out through 3 different routes. This share of steel production is very unique to India when compared to the world due to the ore and the coal availability. Currently, blast furnace BOF route contributes to around 47%, DRI scrap routes contribute to around 20%, and induction furnace route contributes to around 33%. However, these trends will not going to remain same in the near future. Currently, the steel industry is among the top 3 polluting industry in the world. It contributes approximately 8% of the total carbon dioxide emission of the world. As per 2015 Paris Accord, steel industry must try to reduce their carbon footprint by minimum 50% by 2030. Thus, the future of steel making will depend on how environmentally sustainable it becomes to meet its sustainability challenges. We have been hearing usage of hydrogen in the steel production, but making green hydrogen and its commercial viability is still less visible in the near future. Till then, we need to continue with these 3 options of steel making, but by making it more sustainable. If you'll see, following are the list of sustainability challenges faced by the steel maker by both the routes like BF, BOF route and DRI scrap route and EAF routes. So the first most important challenge what steel makers are facing is the environmental sustainability. Reduction in the overall carbon footprint and greenhouse gas emissions. On an average, it contributes 1.9 tons of CO2 for every tons of steel production. Similarly, in case of energy consumptions, it is around 20 gigajoules per ton of energy is consumed for producing 1 ton of crude steel. These are the world steel figures which I have taken based on the average numbers. Then the conservation of the natural resources is one of the important challenges which have been till now not covered in the earlier presenters. The exploitation of natural resources directly and indirectly done by the steel making is creating an environmental hazard. Similarly, a lot of hazardous material and hazardous waste is being created by the steel makers, which are actually resulting into various environmental hazards. Then the second most important sustainability challenge with the steel makers is the social sustainability. That is the people safety and the human capital. The safety first. A lot of incidences of safety has happened in the inside the steel plants, which is making the steel operations very hazardous and unsafe practice. So it has to be measured in terms of the lost time injury rate. Then the third most important sustainability challenge is the economic sustainability. Here the thirst is required for the new products and technologies to come out of the old processes and the traditional way of making this steel. So how does Calderys sustainability challenges what are the Calrys solutions for the sustainability solutions to the steel makers? The first solution is the replace. First, just like steel industry, refractory manufacturing is hugely energy intensive process. In India, we consume close to 3 million tons of refractory, out of which 60% is fired bricks, while only 40% is monolithics. If we add induction furnace route, silica ramming mass, then probably the monolithic share will increase, but not substantially. However, in countries like Japan, South Korea, and developed European countries, the share of monolithics is around 70 to 80%, as compared to India's of only 40%. As per if you look at the table, the norms of energy consumption per unit of refractory produced, you could see the monolithics contributes to at around 10 kgs of coal equivalent per ton of production. While in case of fired bricks, silica bricks, high alumina bricks, fire clay, magnesia base, mac chrome, dolomite, steel ladles, it ranges from 172 kgs of coal equivalent per ton to almost 338 kgs of coal equivalent per ton. So if steel makers start consuming more of a monolithics in place of bricks or fired items, they will help in reducing their overall carbon footprints. We have done a small assessment of the energy and emission reduction by increasing the monolithic ratio. So let's say if the monolithic ratio among the steel makers increase by 5%, that is at the current level it is 40%. If it goes by 5%, that is 45%, the steel makers will help in environmental sustainability by reducing their coal equivalent by almost 30,000 tons per annum. If that same monolithic ratio over the bricks is increased to 10%, it will contribute to around 60,000 tons per annum of coal equivalent. And by 50%, it will contribute to around 90,000 tons per annum. Similarly, there will be a reduction in the carbon dioxide, a lot of sulfur dioxide and nitrogen oxides will be reduced subsequently by that. Calrys, being the world leader in the monolithics, can help the steel makers in replacing these bricks with the monolithics by providing support in terms of in-house designing, engineering team, and application. Then the second important aspect is the second R of our sustainability solution, that is reduce. In the past, most of the refractory raw materials were abundantly available to the refractory makers, which led to its lavish use. Even the steel makers still continue to procure the refractories based upon age-old chemical specifications. Little effort is made by the steel makers to match the refractory properties with the specific application condition. It is often misconstrued among the steel makers that higher alumina will always give better performance. Thus, there is a huge demand of these grades of raw material, which may not be required for the end application, thus leading to the exploitation of the natural resources. Therefore, Calrys, with its technology and know-how, provides the solution unique to the need of the processes without exploiting the natural resources. Like in terms of, for example, in an integrated steel plants, they'll issue an inquiry of more than 3,000 tons of 90% alumina castable. That particular refractory will be used right from the coke oven, sinter plant, captive power units till the end of the reheating furnaces, without even capturing about the specific application processes. We have been successful in designing the processes with much lesser alumina and much cost-effective solutions, which can help in getting the higher life and lowering down the specific consumptions of the steel makers. The third important aspect, the third R of our sustainability solution is the recycling. We know that we currently in India consumes around 3 million tons of refractory annually, out of which let's consider 65 to 70% of the refractory is worn out in the process. Still, 30% of the refractory is wasted as a residual lining. That is this close to around 1 million tons. These give rise to a huge market of recycling within this refractory is for making a new refractories out of these worn out refractories. Following table shows, if you'll see, we have tried to compare the destination of the worn out refractories over 2 decades. 2 decades earlier, the worn out refractories, only 10.9% would go into recycling, 11% will go into a slag conditioning, 37.6% will go into a roadbed material, and almost 40.1% will go as a landfill of the material. This is a huge wastage of the natural resources. However, after these 2 decades, now in the current scenario, we'll see almost 32% of the refractories going into recycling, 38.2% is going into slag conditioning, 29.6% is going still as a roadbed material, which is still a wastage of the natural resources. Here, Calgary would like to capture the recycling part and would try to use those worn out refractories into their manufacturing of the new refractories. The next solutions, sustainable solutions, are the energy savings. There are three ways in which heat is transferred through the equipment into the steel making processes: through conduction, convection, and radiation. Calgary's innovative plastic solutions help steelmaker to reduce the heat losses through conduction and thereby saves the energy. With our new baby high seal solutions in our basket, we are further helping the steel makers in reducing the heat losses into the reheating furnaces, ABC DSCs of the DRI kilns, pellets, sinter machines, etc. In integrated steel plant, in one of the integrated steel plant in 250 tons per hour plate mill, we have been able to reduce their heat losses from the roof as well as from the side walls by almost 20% to 48% by using a specific grade of refractories called as the plastic refractories. The fifth solution comes as the mechanized installation. Safety and valuing human lives has been one of the most important sustainability index amongst the steel makers. Steel making involves temperature above 1600 degrees Celsius with complex reactions and gaseous emissions. It creates extremely unsafe conditions for working. Thus, Calgary provides the solutions of advanced mechanized techniques to do the repairs of the furnaces. For example, robotic shotcreting, robotic gunning, electrical dryouts, online hot patching, and thermal audits to detect the residual linings are the key initiatives taken to make the safe working condition inside the steel makers. Then the last one of the sustainability solutions what Calgary offers is the hazard-free manufacturing and the raw material. Many refractories used in steel makings are made up of hazardous chemicals like tar, pitch, chromic oxides. These are carcinogenic in nature. Operators working at shop floor using these refractories are susceptible to these health hazards. Zirconia-based refractories are now popularly being used into the steel making, but due to its superior property, but without considering the effect of the radioactivity of the zirconia. Calgary's sustainable solutions provide superior quality of gunning, hot repairing material, which replaces chromic bonds with sulfates, thus avoiding the carcinogenic effects amongst the users. Similarly, our new-age tapol clay line at Nagpur will help produce the eco-friendly resin-based tapol clay to avoid the health hazards amongst the operators. Our high seal solutions provide extremely good alternatives to the fibrous ceramics insulators, which are now banned in most of the European countries. Thus, Calgary's sustainable solutions help the steel makers in achieving their sustainable goals by reducing their carbon footprints, reducing carbon dioxide emissions, conserving the natural resources, reducing the energy consumptions, and increasing safety and hazard-free working conditions. That's all. The last line is sustainability should not be creating a complexity where simplicity will only suffice. This is the humble submission from our end. Thank you.
Thank you very much, Mr. Soni. So do we have any questions for Mr. Aditya Soni from Calgary? So if we don't have any questions from the panel, then I would now move on to our next panelist. We have Dr. Narendra Kumar Mishra, R&D Head, India, West Asia and Africa, RHI Magnesita India Private Limited. And also, I would like to thank RHI Magnesita for being our refractory partner. So over to Dr. Narendra Kumar Mishra.
Thank you, Ankit. It is a good evening indeed. And I think we have talked a lot on the BF, BOF, and electric arc furnace steel making route. So considering this pertinent subject, I want to share my screen over here. So little bit time I am taking. So RHI magnesita is, I hope my screen is visible.
Yes, we can see.
Okay, thank you. So RHI magnesita is the leader in the refractory manufacturing for specifically for the steel and the ferrous and non-ferrous as well. So the major production centers spread over by RHI magnesita over 28 countries worldwide, and the endeavor by RHI always to have backward integration, to have raw material as the security and facility of the refractories available to the customers, nearer to the customer's facility. And in India, we have 3 major manufacturing facilities. One is Bhiwadi, another is Vizag in Andhra Pradesh, and Cuttack. Recently, we have added maybe last 1.5 years, 2 years time. The product groups at our Rajasthan Bhiwadi facility is ISO shapes, slide gate plates, lances, PCPF, nozzles, and castables. At Vizag Steel, we are manufacturing some carbon-based products, high alumina bricks, lances, and PCPF and castables. This again, you will find that some products are manufactured in different places. This is just to meet the customer's requirement nearer to the facilities. And the last one which I've added is the magnesia carbon facility manufacturing in India. So these are all our Indian product portfolio, product basket, but RHI worldwide manufactures the products, having the raw material facility nearer to the raw material facility wherever it is available, and the facilities, production facilities available worldwide, and we select the best of the class of the raw materials and manufacture and supply worldwide. So if we consider the BF area worldwide, our products are there for the blast furnace and blast furnace stove refractories, covering, of course, the alumina bricks and the monolithics. While coming to the BOF, we claim ourselves and we enjoy the customers' confidence on us as a leader on BOF refractories. We supply complete packages on this. Our magnesia carbon bricks for vessel lining is world class, definitely, and it gives, we create benchmarks in the industry. We work to the in conjunction with the requirement of the shop and modify and manufacture the required type of bricks with different, of course, when the vessel is lined, to have cost optimization, we have the designing of the products and the bricks for different zones. Our bottom purging elements, of course, now the thing is, earlier it was, people in the steel industry were facing issues that bottom purging has to work maybe for 1,000, 1,500, or sometimes maximum 3,000 hits. But RHI, with its innovative ideas and world-class R&D facilities, we have improved our bottom purging products, which is almost matching to the vessel life in many of the steel plants in India and abroad. This is because of our selection of varieties of and the type of materials, its crystal size, and its type of binders and its processing technology, thus giving a optimum life which has lower corrosion resistance, lower erosion resistance, and at the same time, it is highly cost effective, and it makes the steel cleaner when the bottom purging is in operation. Our taphole tube and aid for changing the taphole tube is unique. So when the taphole tube normally gives a life of around 100 hits, somewhere little bit here and there. More, in some of the cases, it is 150 hits also. But the changing of taphole tube is a bit cumbersome. It takes time consuming. Sometimes if the taphole tube is not changed, is very fast, maybe in 20-30 minutes, then you are losing one hit in a day. So you lost a quantum of money by not producing the steel. Then we have the package of slag arrestor, and somewhere, wherever there are requirement of laser imaging and gunning, it is also supplied along with that, and we do measure and improve the life of the BOF to meet the customer requirement and even excel. So as a global leader for BOF package solutions, and we enjoy #1 position and choice by the users. Coming to the DRI and EAF steel making route, EAF refractories covering the following product group we supply as package along with the services. Our working lining magnesia carbon bricks, as a true global leader, we perform our best and we enjoy #1 position in the industry. If we consider our share in the market, we are having the lion's share in the market because of our performance. Maybe the cost is per ton cost may be high of our products, but the cost economics makes us very comfortable and comfortable for the users to choose as their partner for the refractory supplies. Our drive hybro mass anchor hearth series, there is products for cold ramming, products for hot repairs, hot fettling. It has unparalleled performance globally. This is because of the type of raw materials and the process technology we adopt at RHI Magnesita to give the end products and give the customers requirement, and we fulfill the requirement with great satisfaction. EVT and directional purging plug blocks used in the electric arc furnace, of course. It is a replaceable item, but if you can give a product which can give better life, and if you do not require to change, so the electric arc furnace user or the Konark users, they feel secured. There is no position, no requirement for the stoppage for change of these blocks. So it gives the productivity at the same time. If a product gives higher life, that means the erosion is less and the less of refractory material going to the steel. So it is one way giving the better cleanliness by using our products. Our basic gunning material, electric arc furnace delta for both PCPF and monolithic, we supply in both shapes. Either it is PCPF or it is, in some cases, customer demands it is monolithic and to be delta to be prepared at site. So both way we are meeting the customer's demand, and we are also performing well in both the cases. Our basic gunning material is also a very good material. Of course, some of these materials we are not manufacturing in India. Delta, definitely we are manufacturing. Monolithics for the delta we are manufacturing in India, but almost the rest of the products we are sourcing wherever in India, wherever in the world it is the best from those sources. It is being sourced and supplied to the customers in India, to our partners. So RHI is a refractory solution provider, equipment and service package for the performance, optimum performance. We believe that only sales and purchase will not give you the optimum performance, because the designing, the services, we have the expertise and we give in total package, and we have proved that it can give best output to the steel users with lowest cost. Coming to the downstream, we have, if you consider the BOF or EAF, we have to follow in the same line that steel ladle is to be there and Tandis is to be there. So we supply all the products for the steel ladles, all functional refractories, slide gates, birching plugs, lances, and of course monolithics for the ladle applications. Special refractories like refractories for RSD gassers, snorkel, for secondary steel processing. So these all, some of the products definitely we manufacture in India, and some, because RHI is the global manufacturing facility, having global manufacturing facilities, so we source the best in the class and supply to our customers in India. Tandis refractories, mostly we manufacture in India. Whatever we are supplying, we are also making good amount of export for Tandis refractories worldwide. The monolithics for backup and working lining is our products in both the facilities at Vizag and in our Bhiwadi plant. Tandis furnitures in both way it is there. It's suiting to shop's requirement. We make design and prove it that this is suitable requirement for the Tandis to control the flow and having less turbulence, less of erosion in the Tandis lining, and it gives optimum life desired by the shop and the process. So the ISO products, as I have covered, that we are manufacturing in Bhiwadi, we are supplying to Indian supply customers, and we are also supplying to the many European countries and also the worldwide. So to sum up, RHI continuously innovate and to upgrade the products. It brings new generation refractories, reduce specific consumptions, and save precious minerals in turn, because if you have less of erosion, higher of life, so probably you can make or manage with one lining or one set of refractories, where probably you may be requiring in other cases 1.1, 1.2. So that is the reason that you may be consuming more and more of natural resources to manufacture the same. At the same time, the debris is generated from qualities which are not up to the mark will be piling up, and will be just my previous speakers also touched upon this, that we will be creating the hazards, where there will be hazards created out of these debris, and there will be safety concerns and many things. So to sum up, so again, I want to say we continuously innovate to upgrade the products, bring new generation refractories to suit ever increasing demand of newer type of steel making and cleaner steel making. We reduce continuously the specific consumptions in selected areas, save precious minerals in turn, and give best performance in the class. So thank you all for your patience hearing.
Thank you very much, Mr. Narendra Mishra. So do we have any questions for Mr. Mishra? Okay, I don't see any questions or not in the chat as well. So thank you very much, Mr. Mishra, for your presentation. I would now move on to our next panelist.
Thank you.
Yeah, thank you very much. So our next panelist is Dr. Andreas Möttke, Vice President, Global Technical Services, Dalmia OCL, Germany. So over to you, Herr Möttke.
Okay, thank you. Okay. Just a moment. Can you hear and see me?
Yes, we can see the screen as well. So everything is fine.
Sorry, I have to start. Okay, thank you and good evening from Germany. You know, Friday the 13th in Europe is not the best lucky day, but as we have this intensive and exciting webinar, this specific Friday becomes a very lucky day for me, and I think for all the participants as well. So my colleagues have already explained interesting developments and challenges of the refractories for the different steelmaking routes. However, I hope that I can provide some more interesting information. So we have discussed a long time on the routes for steel making, BOF and blast furnace route, as well as EAF route. The demand of steel in 2020 in the world was roughly 2 billion tons of steel, and 70% of it was produced by the BF and BOF route, and 30% by the DRI, scrap, and EAF route. An interesting fact is that in India, approximately 27% of the steel is nowadays produced by induction furnaces. However, within the next decade, due to the global target to lower the CO2 emission and slow down by this the climate changes we have discussed the whole day on these items, the share of the EAF steel will rise significantly, not only in India, but in the rest of the world as well. Looking to the refractory consumption, this picture shows the share of the refractory consumption by the different equipment. When these figures for the route A, this is a classic BOF route, is resilient. For the route B and C, this is the EAF, DRI, and scrap route. Due to the wide range of the production routes and facilities, for example, use of DRI or only scrap type of furnace as EOF, CONARC, DC furnace, AC furnace, and due to the different steel grades, for example, carbon steel or stainless steel are produced. So these figures are more an estimation compared to the BAF and BOF figures. Globally, the refractory consumption for steelmaking is around 20 million tons per annum, what means that we have a consumption of roughly 10 kilograms per ton of steel. And this figure is stable since a long time. The share of unshared products for the roads B and C is significantly higher than for the road A. This is mainly because of the use of gunning materials and ramming mixes for the ERF. Look now at the refractory consumption in more detail. Today, approximately $10.5 billion per year are spent for the route A, when for the route B and C, the global refractory spend are roughly $4.5 billion. Comparing the total refractory costs index, it becomes clear that they are for the route A slightly higher than for route B. This is mainly due to the coke oven and BF refractory consumption. Just talking about the BOF and EAF itself, the consumption per ton of steel differs significantly. When the consumption for the BOF is below $1 per ton, it will be for the EAF more than 50% higher. However, the share of the refractory cost on the total steelmaking cost is marginal compared to the other inputs like raw materials and energy costs. So an appeal to the steel producer would be to give the refractory industry the space to be proactive in the market and making innovative and environmentally friendly products, and supply so a contribution to the green steel targets the steel industry has. Once you examine the typical refractory demands, it becomes clear that they are for the same for every route. So for the BOF route as well as for the DRI, scrap, and EAF route. Talking about the bright side of the refractories, one can say that there are ongoing innovations enabling to produce this huge tonnage of steel. So without refractories, no 1 ton of steel could be produced. The dark side consists more or less in logistic issues and raw material shortages. Daimler OCL is ready to face any steelmaking route. More than 320,000 tons of refractory products made at its 7 manufacturing units in India and Europe will be supported to produce 28 million tons of steel. This slide shows some examples for innovative products of Daimler OCL. and its partners in terms of environmental friendliness and innovativeness. So by these eco-friendly tap hole clays, innovative arrache mononcles, geo-bonded refractories, which are dried only by 150 centigrades, is lowering the carbon footprint in the production as well as we are targeting for the steel industry. Light white DVM from our partner company is lowering the specific consumption, and the reuse of refractories, recycling of refractories, and made bricks from about 1/3 of recycled materials is another part of this journey to reducing the CO2 emission. Last but not least, aluminum spinal bricks for the steel levels and bowl bottoms will help to zero level the carbon, which is a target of the steel industry for improving the steel quality further. So by this, I'm quick ending my presentation, and I think everybody would be glad that I was not telling such a long time and focusing on only these things we are already not discussed so far. Thank you very much for your attention.
Thank you so much, Mr. Mutke, Dr. Mutke, and let me tell you, I share a very special relationship with all the three refractory producers who are present today. Samir is a very good friend of mine. So is Mr. Parmod Sagar, and so all three of the refractory present today are my very close associates, and I thank all of them for being here and addressing the audience today. So Mr. Ishmohan Garg, I thank him also. So with that, I come to the last two presentations of the day. My very old friend, Sanjeev Manocha, who's the Global Steel Industry Manager for Camus. So he will be talking primarily about use of lime and lime injection in the blast furnaces, perhaps. And I won't limit his timing. You are free to use as much time as you want, Sanjeev. And just after you is the last presentation of the day. So you are the what do you say, penultimate presentation. But as they always say, last is never the least. So
thank you, Dada. Thank you. Really appreciate. Thank you for having me here.
Yeah. Please go ahead.
I'm going to give a bit of twist, if it is okay. I think I've spoken a lot about lime. I don't want to talk anything about lime today. Okay.
Okay.
I just wanted to give. I think we have a few audience left now. Wanted to give a little bit of.
We still have more than 40 people.
Yeah.
And I don't know how many.
200 plus this morning, right? So.
Yeah. So obviously, being a Friday evening, and that
absolutely.
Dr. Andrea mentioned, today is Friday the 13th. So, so on Friday the 13th, late evening, you can't expect everyone to be there. For example, Dr. Mutke, you're near Dusseldorf, right?
Yes, correct.
So the people around your company and your good friends and associates are all enjoying their alt at the Altstadt instead of instead of spending time here. So
yes, indeed.
So it's time to be there at the Altstadt next to River Rhine rather than spend time in a webinar or a conference on a Friday evening.
Yeah, I'd love to be there with you if you go there. Okay, I'll try and come to you.
Sure. Dusseldorf is my favorite city, and my wife also loves Dusseldorf. In fact, I wanted my son to study in Dusseldorf University, but he chose to be in Magdeburg instead, because I wanted him to stay in Dusseldorf and join RWTH in Aachen, because Aachen is again a favorite university of mine. But he preferred to choose. He got into 7 universities in Germany, but he chose Magdeburg. Okay. Ankit, if you can explain a little bit in German.
Yeah. So actually, what happened was Aachen takes admissions in winter semester only, and I joined in the summer semester.
Summer semester.
Yeah,
Okay.
that was
Okay, yeah.
why Aachen was not an option.
So, but Magdeburg for machinery is a very good.
Yes, and I'm studying right now data science, so it is part of the informatic department.
Yeah, that's fine. I think a good choice.
Thank you.
And wish you good luck furthermore.
Thank you so much.
Yeah, excellent. Good to hear that. My son is also data scientist. He studied from Imperial College London, so he's working for JP Morgan.
Oh,
okay.
Oh, great.
So,
Great.
yeah. So
Yeah. So Sanjeev,
yeah,
now the floor is yours. You talk about anything else you don't want to talk about. Line, the floor is yours.
Yeah, sure. I think got a problem with probably you're seeing double screen, right? Just let me just move my second screen out. Sorry, 1 second. You still see double screen, right?
Yes, but that is not really a problem.
Yeah.
Okay. Just remove my yeah. Okay. So I just wanted to give you today a little bit of European perspective, what is happening around here, because there is this decade is really sort of going to be a defining decade for the European steel industry. We're going to change a huge amount of I would say the way steel is produced today, the way steel is consumed today, and things are happening very, very dynamically. As a lot of speakers said this morning. I mean, for you afternoon, for me it was morning, but really enjoyed the session actually with very deep insight. I mean, just about Carmeus, we are the largest lime producer. I won't take much time, and we sort of supply to more or less all the countries around the world. And what Carmeus does, basically, that we are not only lime supplier, we look at I mean things beyond lime, like value in use for not only lime, for all other raw materials. We look at application technologies. We look at all the captive kilns to outsourcing, digitalization, mainly related to lime, and also CO2. So we have a lot of focus going on CO2 emissions. As probably you would appreciate that lime is such a thing that you bring CO2 with calcium carbonate. So you have to get rid of the CO2. And this is something a huge challenge to us in Europe particularly. So just going into the topic for today, in Europe, as you know, that we still have the BOF technology is still dominated. I mean, if you compare it as compared to India, or even if you compare with US, we still have very old blast furnaces which are still running. The oldest blast furnace, which is still in running condition, is built in 1923. So you can see that how European sort of steel industry is still working, right? So people are still managed actually to have those blast furnaces. Although average capacity of the blast furnaces is still very good compared to international standards, 2,500 tons per day. But in UK, just an example, that we have 3 out of 4 blast furnaces, they were built in 1950s. So, I mean, yes, it's a time basically for these blast furnaces probably to sleep now and get some new technology to replace and be more environment friendly. On a little bit about how the capacity evolution has been happening over the last couple of decades, we can see that in the blue line on the top, this is the blast furnace BOF capacity, how it has been declining a little bit over a period of time. And this is electric arc furnace. So it's very slow transformation was already happening before we had this environmental hype, if you want to call it. So it was just sort of because of the competitiveness of the mills and how the mills were reshaping itself. But this is for other EU, which is of course Turkey is the dominating sort of country in other EU when we call it. So you can see an era when we had boom in 2008 and 2009, how the things were moving very quickly from 2007 onwards until 2012. So these 5 years, the capacity in Turkish market has gone more than 100%. So it's more than double actually, from just 15 million tons to 35 million tons of the steel capacity. So there has been stagnation for last about 5 years. But now, because we have another boom in the steel industry, the electric arc furnaces, some of the steel producers, without naming them. They are further increasing their capacities now. So we'll see in 2022, 2023, there is an additional 5 million tons at least coming up in Turkey, and that is through electric arc furnaces. So this is the sort of couple of decades where I've just put up the victims, those who have been the victims in the last couple of decades, how they have been put into sleep. Those majority happened in 2012, 2015. A lot of electric arc furnaces also, they lost sort of competitiveness in the market. A few of them from UK, because in UK we have very high energy costs, so they could not survive that sort of competitive environment when the steel was being dumped from China. And then secondly, sort of blast furnaces also, they were down, like in Liège, if you talk about, or if you talk about SSI in UK. So we have some kind of capacities going off the line completely. And then recently one is Krakow, which ArcelorMittal has decided to close this plant forever. And from 2020 onwards, so this plant is the last victim of losing competitiveness. Now, what is happening here in Europe now is that the media is very hot. Everything, if you pick up media, Financial Times or any newspaper, every day they are covering steel. Every day talking about that what new steel technologies, what new steel plants are doing, and also they are talking a lot about how the transformation is happening in the consumer mindset, that we are moving away gradually from using fossil fuel vehicles to electrical vehicles. And to be honest with you, I mean, I'm also looking to change my vehicle, and I'm looking for electrical vehicle rather than going for fossil fuel vehicle. I think we all have a little bit of change in our mindset now. And so things are definitely moving very rapidly over here in Europe, where consumers, where industries, everyone is thinking about sort of going more about carbon neutral rather than sort of spending any money on the fossil fuels now. So this is the emission in total emissions, what we had over the last 15 years. Per year, this is the data which you can fetch from Eurostat. That, as you can see, there is a slight decline in emissions from the European steel industry, EU28. This is including UK before Brexit. And but this emission, if you look at the emission intensity per ton of the steel, there's not a significant improvement. It is just the reduction. A majority has come mainly from the reduction in the production. And so this clearly indicates that probably, although we say that European blast furnaces, BOFs, are operating at the best available technology, but in the last last decade or so, we haven't done much actually to reduce carbon footprint, even from the blast furnace BOF. So I think probably the blast furnace BOFs are probably already at the theoretical limits now, where you can't do much rather than going into the solutions, which we all know that what solutions are, right? Now, despite having EU ETS, which was very successful, I mean, people call it really sort of a benchmark for putting a price on the carbon. So you know that phase one, which started in 2005, it was just a sort of the first test method. It was just free quota to everyone, but just a first test method, which will happen to carbon border adjustment mechanism again. Phase two was the real thing when they started really putting sort of cap on how much emission you can have. And phase three was one of the stringent one, which was the first, I would call the real first phase, when they benchmark with the top 10% top 10% performers. And so I've given the sort of numbers over there that coke ovens, sinter plants, BF, BOF, and electric arc furnace. What is the benchmark for each and every sort of unit of the steel plant, that how much they are supposed to emit, and beyond that they have to pay CO2 price. And phase four, they further skews those numbers, and they still give the sort of the numbers which are bit tightened as compared to phase three. But there's still a lot of free allocation available to the steel industry, so they're still enjoying, I would say probably 15% approximately of their production they will have to pay carbon footprint, but generally they are not. CBAM, which is carbon border adjustment mechanism, which I will talk in the next slide, but this is a new thing which is coming up in Europe, and hopefully this will further bring a little bit more tightness to the steel market, steel industry on emitting carbon. On the right-hand side, you can see that how the steel sort of CO2 prices have evolved over a period of time. As you can see in the last year, I mean, especially in this year, the CO2 prices have gone skyrocket high. I mean, no one did anticipate that the price will go to 57 euro a ton. But that is something, again, very, very serious. Even if you pay 15% of that 57 euro per ton, and 85% is free quota allocation, is still a huge chunk of money for 2 million ton steel plant or 4 million ton steel plant. So they still end up paying a lot of money actually for the CO2. So there is an urgency created by ETS, and there is also an urgency created by consumer demand, and that's why the steel plants have no other choice but to work on the technologies to reduce their carbon footprint. So CBAM, just a quick overview. I've listed over there that there are total sort of 5 industries which are being targeted for carbon border adjustment mechanism: cement, electricity, fertilizers, aluminum, and steel. So the sort of CBAM is being designed in a way that it will be 2023 to 2026. It will be like a testing sort of period, and 2026 onwards, they're going to put a cap. Every year, they're going to reduce 10% of your free quota allocation. So whatever the target, what are the free quota you have in 2025, an example, 100%. In 2026, you will have 90%. And by 2035, you will have 0% of free carbon. So it means that the steel plants have to really expedite. If they were thinking about putting electric arc furnace, or if they're thinking about putting CCS, CCUS, they will have to expedite everything, and they will have to do it tomorrow, not sort of waiting for that period actually, then when they can do it, right? So this CBAM mechanism has really created an urgency, not only for Europe. I think a lot of speakers also mentioned this thing, but also for exporters into Europe. So I think they will have to really get very fast to meet the stringent requirements what is coming from the Europe if they want to export to Europe. Otherwise, they will not be competitive to supply steel to Europe. So options, I think there was a lot of discussion this morning, whatever was happening about carbon capture, direct carbon avoidance. So these 2 technologies, again, in Europe, I would say, like initially ArcelorMittal and Tata Steel, the 2 big ones, they were really looking at carbon capture. But now you'll hear that they're also gradually moving toward direct carbon avoidance. Probably carbon capture is not the ultimate solution. It might be a sort of a solution which may like be a step towards the direct carbon avoidance. So, but still, there is a lot of work going on direct carbon capture, like someone mentioned this morning about LanzaTech technology, and bioethanol, and all the stuff which is happening around. So, last couple of slides only, that we in Europe over here, then most of the European steel mills have already committed that they will be, or they have pledged that they will be reducing the CO2 emission by -30% by 2030. So for us also in Carmeuse, the lime producer, we have also done a pledge that we will also reduce our CO2 emissions by -30% by 2030 and be carbon neutral by 2050. ArcelorMittal is exceptionally doing very good, and they said they will do -35% by 2030, not -30%. So they're a step ahead of the rest of the industry. We also know that there are 14 blast furnaces which are due for reline by 2025, give or take ±2 years. You can stretch the blast furnaces. But some stage, these companies have to make a decision whether they want to reline the blast furnace, spending 50 or hundreds of millions of dollars on these blast furnaces, or they will move into electric arc furnace. So when we are monitoring that what is happening around in the industry, only 2 have decided out of 14 to reline the blast furnace, and rest are either going towards electric arc furnaces or they have not made a decision yet. So they are still thinking, they're still weighing on the technologies, whether they should go for carbon capture or they should go for DRI electric arc furnace. I mean, this is something, I think, a huge debate within the steel plants are going on, that which technology probably will be better for them going forward. So as you can see at the bottom of this slide, so these are the companies, those already announced. Either they will go with DRI hydrogen, DRI plus hydrogen with hybrid technology, or they will go with DRI electric arc furnace, or they will go with scrap electric arc furnace. So there is a transformation which is happening already, but many companies already decided to move into electric arc furnace route, and also DRI with blast furnace. ThyssenKrupp is taking an exception of going with DRI blast furnace. So there are a number of things happening around over here. And what we are doing, this is my final slide, as a lime producer, what we are doing for the steel industry and for ourselves, that we have our own value in use model, which is not just limited to lime, which can be used for one grade of iron ore versus another grade of iron ore, which can be used for one grade of coal versus another grade of coking coal, and lime versus lime, to compare which one is good for the steel industry. So this is our model, which we have developed with the University of Warwick. Then we have huge expertise on the application of the lime in the steel industry. As you can see on the top right, that by just changing, this is same quality of the lime, there is nothing, no change. With the same quality of the lime, by changing the application, you can reduce your basicity requirement in the electric arc furnace from 2.5 to 1.75. And you can make a better foamy slag in the electric arc furnace. It's a no-brainer. It is something which steel industry must get. So lastly, we are working as lime as a solution for decarbonization. So lime, as you know, CaO has got an affinity to CO2, right? So we produce calcium carbonate from calcium carbonate, calcium oxide, but calcium oxide can be carbonated back again into calcium carbonate. So this can help to absorb CO2 from the atmosphere from the processes. So we are working, a huge amount of efforts are going on within our company to look at the possibility of lime as a solution for decarbonization, not only for slag formation, but also for decarbonization. And then also we are decarbonizing lime. So that how to take out the CO2 and how to use the CO2. I mean, we have a project which we just recently started, we call Columbus project, together with ONG. And this project is already in the pipeline, which is trying to decarbonize lime. So yeah, a lot of things are happening. I think very interesting times. I'm enjoying here, and thank you very much. If you have any questions, happy to answer that.
Thank you, Sanjeev. And it was really interesting and learning experience for me as well.
Thank you.
Whether carbon capture or carbon avoidance is the way forward.
Yeah.
A good choice. Yeah. So with that, we move on to thank you, Sanjeev, and just stay with us for a few more minutes for the last presentation. Dr. Otmar Janash from Smart Steel Technologies will be delivering the last presentation of the day. And I can see his topic is switching from BF to DRI-EAF. So over to you, Dr. Janash. What solutions can smart steel technologies offer to choose the right route, either BF, BOF or DRI-EAF? Over to you, Dr. Janash, to pull us through the end of the day. The last, once again, the last, but never the least.
Exactly. Thank you so much for giving us the chance to conclude the day a little bit. Thank you for the invitation. Thanks to all the speakers before who have drawn up a great picture of the situation. I try not to repeat too much what happened so far. So Smart Steel Technologies is an AI company, and what we are doing is we provide AI solutions and combine this one with technological know-how in order to move the rule-based steel production to an AI-based steel production. And thus we just take all the data which are available, and we use them to reduce not only the energy consumption, carbon efficiency, but to increase quality as well. And we are successful with this one, applying ready-to-use AI. So as we learned during several sessions of today, the main carbon emissions are caused in the sintering plant, blast furnace plant. And what we are doing is we take the whole process chain into account and address current CO2 and energy inefficiencies. So we do not change any hardware or any equipment. We just take all the data throughout the whole process chain into account and find out what is the best process for a low carbon dioxide and energy or carbon dioxide emissions and energy consumptions. So this is what we have seen, and previous speakers mentioned the CO2 prices which we have worldwide, and what are we doing. The current situation in a blast furnace is that it is charged with iron ore and coal and coke, and the coke is partly replaced by PCI and natural gas injection, and that is the process steps we take into account for an efficient operation of the blast furnace. Yeah. So in the first step, we we take into account all the measures explained by ArcelorMittal. We are doing that exactly in ArcelorMittal Eisenhüttenstadt currently, and we are working to increase the blast furnace efficiency. And in the first step, we take into account the natural gas injection, mix it with pulverized coal injection, and then in a next step, we the blast furnace will be replaced by a DRI, and as an interim step, one can imagine that green hydrogen, which was quoted a lot today, can be injected into the blast furnace. And finally, in the last stage, natural gas and green hydrogen will be reduced in a DRI reactor or a fluidized bed reactor. That was the topic about the pelletizable ore which is available in this world. And then downstream, we go into the regular process chain, charge HBI, hot HBI, or hot DRI into an electric arc furnace, and then go via the normal signal metallurgy route downstream. And what SST is doing, we take into account all the level 1 energy data, all level 2 process data, all level 3 process data, even ordering data, and we are able to combine this one in a big data platform with an absolute amazing resolution to tackle the last inefficiencies in the process. And when we have all the data together in our SST data platform, we are able to apply our machine learning models to them to find high dimensional correlations which help to optimize the processes per step. So, and so what we are doing, we do a detailed connection between all the energy, quality, and emissions data. We take into account the influences of all input parameters, the raw materials, the product mix to be produced, all the maintenance data, the wear condition of the vessels, and so on. Then we apply our state-of-the-art AI models
compute the exact inputs and outputs, and thus we are exactly able to apply a very detailed report, for instance, to the automotive exposed sheets, which are supplied to the mobile industry, which require an exact CO2 carbon footprint in a moment. And with our detailed reporting, we are not only able to reduce the energy and the consumption, thus CO2 emissions, but even help with certification to get the benefits of low CO2 costs from the government. So, and we were touching the topic downstream, and what we're doing downstream is that we reduce with our SST temperature AI the total temperature level of the steel from tapping out of the BOF or out of the EAF down to a caster by some 10 Kelvin, which results in a lower energy consumption and thus lower CO2 footprint as well. And therefore, once again, we take all the data which are available now, but in data silos into account, we combine them and apply our machine learning models. And finally, we are able to reduce the big step, the big spread in the temperatures, which are at each process step available. We are able to squeeze the range or the spread of the temperature deviations to a very minimum, and thus we are able to reduce the temperature level to bring it exactly at the best operational window to the continuous casting machine, which not only improves the casting quality by better solidification conditions, but reduces the CO2 emissions as well. And this is what SST, as a rookie on the market with the help of AI-based solution, is doing. And this is what we can implement within a very short time, within 4 months only, and without installation of additional equipment. So thank you very much.
Thank you so much, Dr. Janash. Dr. Janash, thank you, and finishing off the day so very well. Now, this is your topic is something which is very close to my son's heart. So I'm sure my son would be interested in making the final comments of the day and proposing a vote of thanks before we say goodbye to each other. I would request Ankit to thank all our panelists, our sponsors, our participants, our attendees for bearing with us for more than what, almost 5.5 hours? Yeah, 5.5 hours. Ankit, over to you to complete the day.
Yeah. So, yeah, firstly, I would like to thank everyone for attending our webinar today. Unfortunately, we exceeded the time limit by 2 hours. So we were supposed to end by 7 p.m. IST, but due to some delays, it extended a little bit, and we apologize for the delays. But we also would like to thank everyone for staying with us for so long, despite the delays, to all the panelists who stayed till the end, to all the panelists who could not but have given wonderful presentations. Thank you all for attending the webinar today. I would also like to thank the attendees, because the attendees today have been very dynamic and have been asking a lot of questions and very involved with the discussion. So thank you all as well. My heartfelt gratitude, of course, goes out to our silver sponsors, Jindal Steel and Power, ArcelorMittal, Nippon Steel, Primetal Technologies, our steel sponsors, Paul Wirth, SMS Group, Danelli, Calderis, Maxis Motion, and our refractory partner, RHI Magnesita, for supporting this event. Without your help, this event would not have been possible. A special thanks goes out to the organizing committee led by Mr. Shubrata Mitra. Due to another meeting, unfortunately, he couldn't be here today, but he and the entire organizing committee has supported us throughout the past 29 webinars that we have conducted. I would also like to thank everyone from the Steel and Metallurgy team, and once again to all the panelists and the attendees for making this event possible. With that, I would like to conclude today's meeting. Thank you all for joining us.
Ciao, 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 ciao.
Thank you.
Ciao. Ciao.
Gute Nacht. Gute Nacht.